Hello, a little voice guy. Hello, and welcome to the Front End Horse live stream. This is Creative Rodeo, and we are here learning about shaders today with my good friend Liam Egan. Liam, how are you doing? Good to see you.
Really well today, thanks.
I botched
Good
the
to see you
intro a
too.
little bit, but it's all uphill from here. Liam, yeah, it's just wonderful to have you on. You've been on Component Carousel before, and
Mhm.
loved having you on. Love your work in general. All your code pens are just phenomenal. Would you like to explain to the chat who you are? Just a brief intro.
Sure thing, yeah, yeah. So I'm Liam Egan. I work for a company called We the Collective here in Vancouver. I have always loved visual and creative programming. My background sort of started in the world of Flash and grew from there into Canvas and JavaScript. And I'm now the director of technology for We the Collective. And yeah, that's my day job. But I really love sort of coding in this kind of way and using shaders to sort of express that creativity.
Yeah, your code pen was always, let me bring it up, always something that I just kind of dip into and I go, how? Because shaders are kind of this other world of the web. I feel like there's HTML, CSS, and JavaScript, and those kind of get like tightly coupled into like the big three. But then
Mhm.
shaders are kind of their own thing. Like, is that fair to say? Am I seeing shaders in the wrong way there?
Not really. I mean, shaders traditionally are sort of a part of the this sort of OpenGL pipeline, right? So they sort of describe how 3D works and how it appears on screen and stuff like that. What we're going to be using it for today is to render images and graphics on like a flat plane. And so using it like that, you can do some really, really interesting things. And people, some very, very smart people out there do some just incredible things. There's a guy named Inigo Kias, I'm
Hmm.
probably butchering his name for sure, who people have probably seen, who's just, he runs Shader Toy, and his
Oh,
stuff is
shader toy.
just utterly incredible.
We won't dig too much into this, but
Yeah, yeah,
chat. If
yeah.
you haven't been to Shader Toy, I think I've like I dip in every few months or whatever, especially like going to see the biggest pens or I still call them pens. The biggest toys, I guess. Uh,
Hmm.
the fact that this character is completely math is just 100% math
Yeah.
just blows your mind. Like there's so much stuff
That's one
here.
of Inigo's shaders as well.
Okay,
He's
so
yeah.
they are IQ. I've seen IQ stuff.
Yeah,
I've like
exactly.
dipped
Yep.
through their things, and it's incredible that this is not like someone going out and photo sourcing anything. It's like all the code is right here. So this is essentially code pen for shaders, right?
Yeah, exactly.
Yeah, that's oh, and Puma says, yeah, that is
Yeah.
in Inigo's piece.
Yeah.
Um, Mind blowing stuff. So we're gonna make this today, correct? This is what we're gonna. No, I'm just
Exactly. Yeah, yeah, yeah. Give
no,
me 12 days.
but this shows like the range and the like ultimate. I think my frames are dipping a little bit. I'm gonna close that out. The yeah, we're down to okay, we're back up to 60, and there's We the Collective. The range of shaders can kind of go from what I showed yesterday, stripe.com. Like this up here is a shader, just gradients moving around, right? It's like it's pretty cool, but that feels a bit more feasible for me as a web developer than the create an entire person or an entire landscape from a shader. So like
For sure.
shaders can be used for the web or for like video games even, right?
Yeah, exactly. Exactly. So like shaders will be used to express basically everything that you see on screen when you're in a video game or on a 3D simulation or whatever. So There's two shaders in the WebGL pipeline. You've got the vertex shader, which is responsible for drawing points on screen and turning that into geometry. And then it sends it through to the fragment shader, which is responsible for coloring it and adding shapes and textures and all of that kind of stuff.
Cool. All right, great. We got some great people in here. I just want to shout out the chat. So Andy and Nikolov's in here. He'll be coming on in a couple weeks, I think, or maybe next week. I need to check. Wilster, we got Nino Pepper. Hey, Thomas, how good to see you. Banana Stand, Lars is here. Great to see a lot of people in here. And Adrian saw you earlier, so fantastic seeing you all. And IVIIXO, I'm sorry, your name's not quick to say, but I'm so glad you're here. Amit, fantastic people in here. Yeah, I'm so glad you're here because we're gonna learn shaders, people. We're gonna do it. I want to walk away from this basically learning enough to kind of be able to bust one out in a project, right? So like nothing too fancy, but I'm throwing together a quick code pen. It would be cool if you had like a moving gradient shader in the back here. I know how to do that, right? Or at least like I know how to reference the thing that I've done before, right? Like, because that's usually good enough. If you can go to a thing and pull some code from that and know what each part kind of does, that's going to be a win for me. So, should we pull up that boilerplate? Should that be kind of where we go first?
Yeah, let's start there. I might have a quick talk through
please.
what we're setting up here, just because it is, this is sort of our boilerplate code. So
and
this
super
code
quick.
Here,
I'm so sorry to cut you off at the very beginning. Do we want to share this as a template with the chat? Perhaps we did that with I think it was with last week from Steve. We shared it as a template. How do I think you might have to do that on your end. I'm not sure.
Oh, I do. Okay, hold on one sec.
I don't know how to.
Template. Let's see. There it is.
Is that cool?
So I'll copy and paste the URL into the chat here.
Thank you so much. Really appreciate it. Yeah. That way chat can kind of play along, and also they have that as a resource forever. Cool. Thank you, Liam.
Yeah, no problem. So we're using Three.js here, just because it's sort of the framework that most people know best. So really all I'm doing is just importing all the bits and pieces that I need from the Skypack version of 3.
Cool.
For right now, let's just ignore this fragment shader string
okay.
up the top here. I might actually move that because we'll get back to that.
Yeah.
So if we scroll down,
cool.
I'm just calling an init function. So I'll just step through this really quickly. Really all it's doing is setting up an orthographic camera.
Okay, which one's that? Is that the one that yeah.
It's the one that doesn't have any sort of perspective to it. So it's just like everything it looks to, it's exactly the same size regardless how far from the camera it is. Yeah. So then I am creating a texture and just loading a noise texture in here. So if you were to open that up, you'd see what that it's just sort of like a square noise texture.
Am I missing that? Sorry, where's that?
So just below. Oh, sorry. I'm looking at a slightly different one. I'll come back to that. So then you've got your uniforms.
Here we go.
So in shader nomenclature, uniform is like a constant variable. So it's a variable that is just set from JavaScript, and it's just available to the program for use wherever.
Okay.
So the two uniforms that I'm supplying is iTime and iResolution. One is sort of going to be a ticking time on the request animation frame loop, and the other one is just the resolution of the screen that it's currently rendering to.
Got it. And is the I like a
you can really call them whatever you like.
Okay.
Using the lowercase I as a standard that you see on Shader Toy, so it's just a way to denote that this is a uniform coming in from somebody.
Awesome.
I've seen it with a U underscore under it as well, and stuff like that.
But that just lets me know it's a uniform, and that's like a thing that I'm setting. Cool. Awesome.
Yeah, exactly. So then just creating a scene, creating a plane geometry. So plane geometry is just a square plane.
Right.
And then just adding that to the scene. and rendering it. So
Okay.
it's really pretty straightforward. So this is all really boilerplate 3GS code, but if you want to deeper dive into it, we can sort of have questions later on.
I think this part I totally guess. So if I can
Mhm.
just say it back to you, so this is really just creating a plane and showing it on screen. Like that's pretty much all we're doing here. And then we're able to pipe in this init material, which is going to be using our fragment shader and these uniforms. So
Yep.
as these change, that'll be able to be passed into our shader. But like this init function really just makes a piece of paper basically and shows that on screen, and we're gonna be doing the magic elsewhere. But this thing, if anytime I want a shader, I can pretty much grab this init function and run with it, right?
Yep. Exactly.
Awesome.
So one of the things here is that this, like, we're not really going to be touching this again, not much at least.
Cool.
We might add a texture to it later on. We might do something like that with it, but generally this is about as boilerplate as you get.
Awesome.
Yep.
All right, cool.
So what we're going to be working in is the fragment shader itself. So one of the things that I normally prefer to do, at least on CodePen, is put this in the HTML tab, just so that, because it's separate then, and you get some nice coloring on it, and it's just
It's
just
the syntax highlighting.
Syntax
you mean?
highlighting.
Yeah,
Exactly.
That's usually where I see it, right? Like
Yeah.
it's most often in the HTML.
Yeah.
Are we
So
putting it
if
here
you
just for ease of use, or are we going to copy it out?
let's copy it out. That way we can
Cool.
just work in the HTML tab.
Okay.
It's easy.
So do I
So if you just
copy all
copy
of
the
this?
whole text, yeah, and then
Okay.
it'll.
Cool. Oh,
You
I
wanna
actually need
create-
to open up your template. Let me do that. 'Cause
Yeah.
that was just yours. All right, cool. So
Sure.
I got my own.
Yep.
Oh, also, I got noise now. Cool. Okay. Yeah, I wasn't seeing the noise on the other one. Awesome.
Aha. There you go.
Cool. And saw some people coming in. Hey, Cody. Hey, Aaron. And Wilster. I might have already said. Wilster says, for me, the template had a third uniform eye noise. Cool.
Yeah.
Okay. Got it. So
That'll
that's
be
the
in
difference.
yours as well. Yeah.
Awesome.
So I was just working from a different thing. So
Perfect.
if you, I'll show you that real quick. So if you take a look at, there's a line 63, I think.
Yeah. Okay. Sorry. I was gonna
JavaScript.
paste this. I was gonna paste this
Oh,
over.
yep.
Whoa! Huge thanks to C147. Thank you for that sub. Really appreciate it. Appreciate that prime sub. That's super kind. All right. So I think I just broke it. Let me just pull this back so we can look at it. Here we go. 60 something.
Yeah. So 63.
63.
So basically, what we're doing here is just loading a texture in.
Cool.
So this just loads a texture, sets the wrapping on it,
Okay.
and then adds it as a uniform. So you'll see
Got
the
it.
third uniform there, eye noise.
Cool.
And that's just a noisy texture.
Yeah.
So
Let's add some
we can
interest
use
to
it a
it.
little bit later. Yeah, exactly.
Nice. All right, cool. So that part we might not use if I were grabbing this again, right? Like
Exactly.
that part in the
Yeah.
init, you could take or leave, but
Yep.
the rest is pretty straightforward. Awesome.
Yep.
Okay, so I should copy this out again.
Mhm.
The void main and all
Yep,
that goes
the
in
whole,
there.
The whole thing.
All right, cool.
And once we've got that sort of set up, so what you need to do here is create a script around that, a script tag.
Cool.
And you want to give it a type of text / shader is what I normally go for. The reason for that is just because you don't want the browser to try and interpolate it.
Okay.
And then you give it an ID. Let's call it Fragment Shader or something.
Cool. And then we want to do something down here where we do a document.
You just want to do like either a query selector or get element by ID or whatever.
Yup. Sounds good. All right, cool. So now we got that fragment shader.
And you want to do inner text. So on
here. Got it.
Yeah, exactly.
Cool.
Hopefully that
we got it back. Awesome. Okay. So we can either have it as a string and pass it in here, or we can use it as a DOM element, or rather, yeah. So put it right in the HTML and just grab the inner text of that. And so
Yeah,
now
exactly.
this is what's the language of shaders?
The language is a subset of C
Okay.
called GLSL. And so a lot of the sort of standards and stuff that you'll be seeing here are C standards.
Okay.
But there's some sort of unique little bits and pieces to the language. So types, for example, there's a lot of math types in here, vectors, matrices, stuff like that.
Cool. And Nikolov,
Yeah.
thank you so much for that sub. Really, really appreciate it. Gosh, you guys are so kind. Awesome. Okay, so I'm not very familiar with pretty much anything but JavaScript and Python. So this is definitely going to be a bit different for me from a
Cool.
programming language kind of standpoint. So if
Okay.
I'm asking a lot of questions, I apologize. But
No, please ask
yeah,
away.
coming
So
from a
let's,
JavaScript frame of reference. So
and that's it, right? Like JavaScript is sort of like a great grandchild of C, really. So a lot of the sort of concepts are familiar, but the syntax
right,
is probably quite a little bit different.
right.
But we can just step through this
Cool.
code really quickly. So this include at the top really just includes sort of a common fragment shader from 3GS. So if you were to go to their GitHub and look for that common file, you'd be able to find it pretty easily. And it sets up some sort of commonly used constant variables, stuff like that. So just some sort of
Oh,
useful bits and
so
pieces.
so that's for 3JS.
Yeah,
That bit.
exactly.
Interesting.
Exactly.
Okay.
Yeah. So that gives us, for example, what else? Yeah, you get like all of the varyings that come from the vertex shader are included in that common file. So a
Cool.
varying is just it's like a uniform, but it's passed from one shader to another.
Oh, okay.
Yep.
All right. Cool.
So what that would be responsible for example, is passing along, let's say the UV coordinates from the vertex shader. So that would be like the vertex shader would calculate where the points exist and then pass that information along to the fragment shader.
Got it. That
Yeah.
way, if my shape is in one side of the or my if my mesh right is over towards the light or something, it can know where it is in space compared with being down there. Okay, got it. So
Yeah,
the fragment
exactly.
shader can get that information. Okay, cool.
Exactly. It's well worth looking into. We're not really going to touch on much
Cool.
from that common file, but there's a lot of kind of cool stuff that's included in there.
Awesome.
Yeah. One thing that is included in there that we are going to use is pi. So there's a constant that'll come from that common include, which it defines pi.
Okay, cool.
Yep. So then at the top, you can see that we've just sort of defined our uniforms. So this is how the shader knows where to bind those uniforms that we're passing
Got
from
it.
JavaScript.
Okay, so are we typing it basically, or also just kind of saying, hey, we're expecting these, kind of like as props, like.
Exactly.
Okay,
Yeah.
cool.
Yeah. So if you were to delete one of those, then it would stop working. So
Got it.
it would still render, but it wouldn't have anywhere to send that variable.
Okay. So
Yeah.
we created the uniforms there. We're passing them in for this shader material type,
Mm-hmm.
and then we're kind of catching them on the other end and
Exactly.
saying what type they are. Awesome.
Exactly. So the types are kind of important here. Being C, it's strongly typed. So a vec3 is a three-dimensional vector. A float is a floating point number. So GLSL will distinguish between integers and floats, which is also important sometimes. And a sampler 2D is just our texture.
And it's an image essentially, right?
Exactly.
Cool.
Yeah. Yeah.
And then the vector 3 is essentially like 3 points. It's like an array of 3 numbers, right? Like that's kind of how I think about it.
Exactly.
Cool.
Yeah. So it's an X, Y, and a Z.
Cool.
Yeah. So you'll have vec2s, vec3s, and vec4s in GLSL. So X and Y, X, Y, Z, and X, Y, Z, W.
And W, would that be like time, or is that something else?
It's just a way to denote the fourth dimension.
Ooh.
Yeah.
Which is time? No, is that not?
Uh, Only physically.
Okay.
I mean, this is used as sort of a mathematical construct, right?
Got
So
it.
you can have four-dimensional space. You can build things out in 4 dimensions and have them rendered down in 3 and then in 2, and that kind of works.
Huh.
Like there's a whole array of sort of shaders out there that will work in 4 dimensions.
Interesting.
4-dimensional space, yeah.
So Puma said that it's the distance from the camera. Is that? Or can that be it? It's fine. If we're dipping into the multiverse, we can dip out. That's fine. If I'm getting into like Loki and Marvel Cinematic Universe type stuff, we can head the other direction. It's all good. Was just curious.
Yeah, so often like you'll use these constructs as well as just useful storage mechanisms, right?
Got it.
Very often I'll use a vec4 to store 2 sets of 2D coordinates, stuff like that.
Sounds good. Sorry,
Yeah.
my dog is barking in the background. I'm gonna try to manually mute for a little bit. Oh, I am failing. I'm peaking and going down.
Sure.
I'm just giving it a shot, but anyway.
So get screen space. We're going to loop back on that one a little bit. I just want to sort of explain how rendering to the screen works before we sort of jump into that, because it's slightly complicated. So if we go down to main image is a special function in GLSL. It's the function that WebGL will call in order just to render everything to the screen. Oh, sorry, main actually is the special function. Main image is a standard from. So if you scroll down.
This. Got it.
All the way down. Yeah. Yeah, there you go. So main is what WebGL will call to render to the screen.
Got it. So it's expecting a function called main.
Mm-hmm. Yeah.
Cool.
Just like every C program. Yeah.
Okay.
And then main image is just it's a convention that I borrowed from Shader Toy.
Okay.
Yep.
Cool. So then
yeah,
that calls main image with the frag color and the frag coordinates. Okay.
Yeah, so let's talk about those two variables really quickly.
All right.
GL frag color and GL frag coordinates. They are 2 special GLSL variables. One is GL frag color is a vec4 that needs to be set to render something to screen. So it will contain RGB and alpha.
Okay.
Right. So in this case, we're using a vec4 to contain a color set. So the only thing that main really needs to do is to set that. So if you were to, for example, copy that.
Just this variable?
Yeah, exactly.
Cool. Got it.
And paste it after main image.
Okay. It's like that?
And then, yeah, exactly. And then equals vec4. And then what you want to do is type in here 1, 0, 0, 1.
Cool.
And
red 100%, green blue at 0, alpha at full. Got it.
Yeah, yeah. So these are normalized values, so there'll be a value between 0 and 1. And yeah, that'll give you the output.
Cool.
So yeah, this will always, whatever value you provide to that, it will clamp it between 0 and 1.
Okay. So if I put 5, it's still just going to be 1.
Exactly.
Good to know.
Yeah. So really, that's all main needs to do is to set that variable.
Awesome.
Yeah. And frag coordinate is the coordinate of the fragment on screen. So I'll explain this really quickly. So this is in GLSL nomenclature, a fragment is a pixel essentially. And so GL Frag Coordinate will contain a two-dimensional. It's a 3D vector actually, but we're only interested in the XY at the moment. So it
Cool.
gives you the exact position, pixel position on screen.
Got it. So a fragment is like a pixel is kind of the mental model I should have.
Exactly. Yeah.
Okay. Now is main being run once for every single pixel on screen? Is that what's happening?
It is. Yeah.
Got it. Okay. So this,
Or
yeah.
rather, it is in this case. It's being run once for every pixel being rendered to screen.
Got it. And that's performant because my computer with its graphics card can run pretty much like all the pixels at once, 60 frames a second, right? Like 60 times, because it's not going like, all right, first this top one, good, done. Next this one. It's able to run main like 1,000 times at a time, 60 frames per second. That's how I get 60 FPS, right? Like it's
exactly
cool.
Yeah. And it's really interesting too. You can dive really deeply into the inner workings of WebGL and OpenGL as well, because it also runs sort of parallelized in other ways, right? So pixels will know, or fragments rather, will know about their neighboring fragments in order to optimize the code that it runs every time. So it's really interesting, the inner workings.
Oh, I thought they didn't know that. That's really interesting. Okay, cool. Got it. I thought it was like I thought main was very isolated in what it knew, and it kind of had to figure out everything from just these two things, but they're able to know about their neighbors?
From the sort of code that you're writing, the perspective of that code, yeah, absolutely. But it's sort of an optimization technique. So when you do get into this, one of the things that you'll start to see is people not wanting to write if statements.
Okay.
And the reason for that is because it creates what's called branches, which means that parallelization has to be run twice. So this is really a matter of sort of interpolating and optimizing the number of fragments that a shader needs to run.
Got it. We don't need to worry about that today, though, because we're just learning.
Exactly.
Like
that's a deep rabbit hole.
We've still got the training wheels on. We're just gonna be sticking to this. We're not looking for like the aerodynamics in our windsuit or anything. We're just trying to get down the street, right? Cool. But yeah, that's fascinating. This whole thing, the fact that you know, we can do so much with shaders. Also, like even this would be very unperformant for like any kind of other way, right? Like doing a simple gradient with a shader seems like it's super performant, super easy once you get the hang of it. Doing this with like CSS or kind of any other way would be pretty hefty on the price of computation.
Yeah, from what I understand, CSS gradients still all on the CPU, right?
Yeah, I mean that's my understanding. Chat, correct me if I'm wrong, but yeah. So that's kind of the big difference is that this is being run on the GPU, where most other things, or at least a lot of other things, are run on the CPU. I feel like some transforms happen on the GPU. Is that wrong? I don't have a great handle on it. If there's probably an expert in the chat that knows which things get kicked from the CPU to the GPU. Basically, chat, the GPU is just better at doing graphic stuff because it can do a whole bunch at once.
Yeah.
The CPU is limited by your cores, right? Is that?
Yeah, exactly.
Cool.
Yeah.
All right.
So let's maybe go ahead and take a look at main image. What I might get you to do is just empty that function out, and we can sort of rebuild it from scratch.
Okay, cool. That sounds great. The comments too?
Yeah, just get rid of everything.
Nice.
Yep.
All right. Main image. Got it.
Okay. So the way this function is built, you can see in the parameters we've got an out and an in. In C, an out is a parameter that is only ever set and not referenced directly. In is the opposite of that, so it comes in, doesn't go out, doesn't get modified essentially.
Oh.
Right.
Okay.
So if you think of any sort of C kind of language, this is like sort of pointers 101.
Okay.
You don't need to include either of those. If you omit them, it's like an in variable. It doesn't matter.
Cool. Okay.
Yeah. So what we've got here to work with is our frag color variable, which we know we need to set in main image, and we've got our frag coordinates. So one of the things that we could do with that is maybe just set frag color to frag coordinates. So if you were to create a reference frag color.
Okay, so completely novice here. How am I doing that? So just type frag color.
Just type frag color. Yep.
Cool.
Just like you did before. So frag color equals vec4.
Cool.
And then type in there fragcoord.x and fragcoord.y.
Comma fragcoord.y, right? Like that?
Yeah, exactly.
Yep.
And then 0 and 1.
Because we don't care about the third one.
The blue and the alpha, yeah.
Oh, okay. Okay, got it.
So you'll need a semicolon as well.
Thank you.
It's pretty strict about that.
Used to that being implied. Cool. Awesome. Okay.
So now our screen's all yellow. And the reason for that is sort of what we spoke about before, where this is going to be a value that's clamped between 0 and 1.
Okay.
And frag coordinates sort of ramp all the way up to the number of pixels on your screen at the moment.
Okay.
Right? So what we need to do, or what the most sort of common convention here is to normalize frag coordinates somehow into what's commonly called UVs, but for now let's call them maybe coordinates. So if you create a new variable above that called, so you'll want to give it a vec2. And we'll call
just
it
start.
Yep. So vec2.
Like that?
Yeah. Exactly.
Okay. Also, super quick, am I imagining it, or are there is there a 1 pixel green line coming down the side and a 1 pixel red line, like either at the bottom or the top? Am I just imagining that, or is that what's happening?
No, you're not. That is absolutely what's happening.
Because that's the point where these are 0, and so therefore red is coming in at 0, but Y exists, so I get this green line because that's there.
Exactly.
And then as soon as we go past the first pixel, it's just yellow from there on out.
Exactly. You could extend that. So if you were to, in your vec4, if you were to divide fragcoord.x by like 400 or something.
Got it.
You'll need to. So the other thing with GLSL is really number types are all inferred. So it currently thinks that that's an integer. So you just need to put a little dot 0 after it to cast it as a
got it.
floating point number. Yeah.
Cool. That's an easy gradient. I didn't expect that to. Wow, that's cool.
Yeah.
Very nice. All right, cool. That was fun. I'm glad we touched on that because that's a satisfying gradient just for dividing by 400. Cool.
Right, exactly. So one of the things about this kind of programming as well is there's no sort of convenient like console log or anything like that. There's no way to sort of see what the values directly are.
Got it.
And so what you'll often find in programming like this is that you need to somehow output the values that you're generating to screen.
Right.
And that's sort of what we're moving towards here.
Okay.
And it's been so often that I've been programming something and I'll want to output what I've calculated, and I do that by just rendering a color to screen. And all of a sudden that's way more interesting than what I was trying to get at.
Fun. Right? Yeah, that's
so
cool.
It's super experimental. It's really cool for that.
So some colors you'll like be walking around the city and you'll see a color and you're like, that's an error color. That's the color I get when my code's going bad.
Right, exactly.
Cool. Chords, we got this.
So chords we want to be between 0 and 1 normally. So this is normally how we kind of define UVs. So what we can do is we can get that by dividing frag coord by our resolution vector. So I resolution. So if you just type that in there.
One. Okay, so frag, was it coord?
Frag coord, yeah, it's just
divided by I.
Yeah, exactly.
Huh.
Yeah.
And then semicolon.
Yep.
Cool.
And then if you just use coords.x and coords.y instead of frag coord.
Okay.
Is that working? Why is that broken?
Frag. Let's make sure I'm typing this right. iResolution.
iResolution might be a vec3 actually, so we might need to cast that down. So if you put, so the way that vectors work, this is probably another important talking point here, is a vec3 will be an XYZ, right? But you can do, I forget the term that they use, but you can turn that really easily into a vec2 by just typing .xy, which will just give you a vec2 of the XY
Got it.
coordinates.
So that's what you're doing here.
Yeah, exactly.
Whoa. All right. Nice.
Yeah.
Okay. So why is this happening? Why are we getting this result? Is what I'm trying to figure out.
So what is happening here? If you were to replace coords.y with a 0.
Got it. That makes sense to simplify it.
Uh-huh. So
Okay.
what you can see here is the red value going from 0 on the left-hand side to 1 on the right-hand side.
Got it. So we're going from having this. So because this is being run for each and every pixel, depending on where it is, at the very left of my screen, this value is 0. So we essentially create black, and then this slowly ramps up to be pure red. So then we have 100% red and still no other values. And then because we're pulling in the y axis here, this is doing the same thing. So if we set this to 0, we'll see the same thing, just up and down and with green.
Yeah, exactly.
Awesome.
Yeah.
Okay, and so the bottom left is my origin?
It is, yeah.
Okay.
So this is sort of this is a slight difference with the way that WebGL works to the way that sort of every other computer works, right?
Yeah.
Yeah. Or every
awesome.
Other
And so
coordinate
that's
space.
why we see black pretty much at the bottom left, right? Like that bottom left pixel is pure black. And then up at the top right, that's 100% red, 100% green, 0% blue.
Yeah, exactly.
Awesome. This is really cool.
Yeah.
Wow. Loving this.
Sweet. Okay. So, now let's start to talk about shapes.
Okay.
Okay. So what we want to do here is create a circle. So creating shapes in this kind of shader, we use the easiest way to do that is to use what are called fields. And a field is basically a description of a gradient of a specific shape. So in this case, we're trying to create a conic gradient.
Okay.
Right? So the easiest way to do that is to say, if you think about this two-dimensional coordinates vector, it has an origin and it increases linearly outwards, right? And so the easiest way to create a conic gradient from that sort of coordinate space is just to take its length.
Okay.
Okay. So let's create a float variable called field. And we'll call a GLSL function called length.
Like that?
Yep, exactly.
Cool.
And it'll take a vector as a parameter. So the coordinates.
So
Chords.
Chords like that.
Yeah,
cool.
Exactly. So what this variable contains is a field which goes from 0 to, however long this coordinate space will extend, using that two-dimensional vector as the source of that. So what we can then do is let's make a new frag color beneath that. It doesn't matter if you reset these things, so you can set them 100 times and it doesn't matter.
Cool. So frag color equals.
Yep. So it needs to be a vec4.
1 second, I was going to handle something in chat.
Yeah, no problem.
Cool. All right. Apologize for that.
Do you
Also,
get that often?
just super quick. I mean, people offering for me to become famous a lot. Yeah,
a lot,
just
yeah,
like
sure.
I'm out in public. No. Gene Timex says hi, Liam. Also, you got a whole bunch of chat. Thank you, chat, for being here. And Aaron, thank you for answering that. Yeah, the only thing that we're using here is 3JS. That's pretty much the only library that we're importing. The rest is just going to be GLSL, right?
Yep, exactly.
Awesome.
Gene Timex, I just want to call him out. He's a guy that I worked with many, many years ago. Probably
Awesome.
like 16, 17 years ago.
Oh, wow.
Yeah.
Gene, welcome. Yeah, great to have you. Awesome. So we got frag color. Now what are we doing with this? Something with the field?
So let's it needs to be vec4, so let's make another vec4.
Cool.
So one of the things that you can do with vectors is you can mix them together. So it needs to contain 4 components, but we can set a vec3 as its first component. So if you want to do that.
Got it. So the field, is that, or?
Yeah, so if you just type vec3 in there and give it like
okay.
a 1 value, for example.
We can do this. We can nest these. Got it.
Exactly.
So 1,
and then
if I just do 1, is that gonna extrapolate that I want it 3 times?
Exactly.
Cool.
And then after that, you just want a 1 for the alpha channel. Yep.
So that should be white. Got it.
White
and that's
screen?
What we got.
Yeah.
Nice.
Exactly. So what we want to do, let's just throw our field straight into that value and see what that
into
does.
the vec3?
Yeah, exactly.
Cool. Now this length, how is length for length, I'm used to like string length, which is just like, 12 if there's 12 characters. How is length 3 values?
So
I don't think I understood the conic gradient bit as
okay, let's rewind that a little bit. So
yeah,
if we're thinking strings, so think of a string as a single dimension, right? So
right.
If we sort of extrapolate it that way, the length of a string is always going to be like a length along a one-dimensional sort of line, right?
Right.
Whereas what we're doing here is we're measuring the length of the 2-dimensional coordinates. So those 2-dimensional coordinates extend outwards from the origin point.
Got it. Okay.
And so what we're getting back here for every pixel on screen is the length of that pixel, that coordinate, from the origin.
On the y-axis and on the x-axis and also on the z-axis, but we're ignoring it.
Exactly.
Is that true?
Yeah.
Okay, got it.
Yeah. So
okay.
This could be extended. So what we're doing here is we're creating a field for a circle, right?
Cool.
If you were to extend this into 3D, that would be a field for a sphere.
Sounds good. Got it.
So what we can see here is that our origin point is the bottom left, which isn't great. So let's change that.
Okay.
By making our origin the center of the screen.
All right. How do we do that?
On the coords, what you do is, so if you go back up to your coords vector,
right here,
and just
cool.
subtract 0.5 from it.
Just at the end here, just tack that on?
Yeah, exactly.
0.5, cool.
Yeah.
And it's bananas 01 says, well, length is the norm of the vector here. And
yes.
Gotta learn math. I'm working on it. It's bananas. I'm trying to learn so many things. So
yeah,
cool.
Okay.
Awesome.
So that centers our field, which is great.
Got it. So minus 0.5 because everything's based on a 0 to 1 scale. So this just moves the origin. Got it.
Exactly. Yeah.
Cool.
Yeah. So now let's turn that into a circle. The easiest way to do that is to use another GLSL function called step.
Okay.
And what step does is it takes 2 values. In this case, we're going to give it 2 floats. And it yields a 1 if A is less than B and a 0 otherwise. So
Got
what
it.
we're saying here is we're feeding it a gradient and a value, and it's going to give us back either a 0 or a 1 based on whether the gradient is inside that value or outside it.
Okay, cool.
Okay. So inside our vec3, actually, let's create another variable here below field.
Cool. Oh, I meant to do this. There we go. Cool.
Let's call it, it's a float, so let's call it mask.
And then you said that was called step.
Yep.
Cool.
And you want the first parameter to be field.
So the first parameter is the thing that we're looking at.
Mm-hmm.
Cool.
And then your second parameter will be sort of the point at which you want the step to take place. So we're looking at a gradient space between 0 and 0.5 because we've centered things, right? So we want it to be below that 0.5. So let's say 0.2.
0.2. Okay.
Yep.
And then do we have another?
That's fine. No.
Oh, just that.
So just 2 parameters. Yep.
Oh, interesting.
And then if you drop mask into that vec3,
got it.
you'll see the result of that.
Instead of field?
Yeah,
Wait.
exactly.
Okay. Whoa. Okay.
Right?
Okay, so at P1 Mine, thank you for that sub. That's super, super kind. That was fantastic. And people in the chat are talking about the book of shaders. Yeah, P1 Mine, thank you so much, Brent. IVI says, Liam, you need to teach Alex and us matrix and vector math. Plus, book of shaders is a very experimental approach, just as Liam's teaching. I love it. So people are really eating this up.
Honestly, Book of Shaders, we should link to that.
Yeah, good call.
Because it's where I learned everything at the beginning, for sure.
I hear this a lot. Bookofshaders.com might not be. I don't want to go there. Wait, what? Oh, the Book of Shaders. Ah, it's such a bummer. That's such a bummer. Oh, man.
Unfortunately, Patricio hasn't updated this in a very long time.
Yeah,
but it's
my understanding is there's no current plans to, right? But for what it is, for the parts that they have finished, I've heard nothing but rave reviews.
There's so much good stuff in here for sure.
Yeah. I've spoken with a few people who have learned so much from that. So yes, cool, good call. All right, so let me just wrap my head around this. So step takes in this value, and if that value is less than the second argument, then it returns 1. Otherwise, it returns 0.
Exactly. Yep.
Okay, cool. So if we bumped this up, it would just make a bigger circle, right?
Exactly.
Cool.
So 0.5, you'll see it takes you right to the edge, and that's because your gradient.
We're starting at 0.5 already, so it's got it.
Exactly. Yeah.
Awesome.
Yeah. So one of the cool things that you can do with that vec3, just to see the comparison between these things, is to drop into the second and third parameters of the vec3 just the field instead of the mask, and you can see the comparison between the field and the mask and what that looks like.
How do I do that?
So just comma, field, and then comma field.
So what's it? I'm not under. Whoa! First off, whoa.
Right.
Second off, it's turning this vec. Oh no, sorry, it's a float. Oh. So this was, for chat, if you pass one argument into a vec2, a vec3, or a vec4, it's going to say, okay, I assume you want this for all the things. So if I say vec4 1, it's going to create vec4 1, 1, 1, 1. I don't know how many I said, but it's going to make that value for all of them. So that's what it was doing here. That's what it was confusing me because I'm like, I thought mask was a vec3, but it's not. It's a float. Okay, so field.
Yeah.
Field. This is a really cool. I'm already happy with this result. That's wild looking. But yeah. So
yeah, it's great, right? So you can see what I was saying before, where you want to see what a thing is, and so you just output that to screen as a color or as a shape, and all of a sudden you see it.
Okay, cool.
Yeah. You start to develop sort of an intuition for these things for sure.
It's like an intuitive console log kind of thing versus actually
Exactly.
like seeing the data. You have to be like, all right, well, if this is red, that means I'm getting the right thing out. I'm getting the wrong thing out. Chat coming through with the confetti. Nicely done, chat.
Nice. Love it.
Cool.
So one of the things about that, I'll just show you real quick. If you expand the window to the left a bit, so just reduce your code window, you'll see what kind of happens here.
Oh. Okay.
And
this does make sense.
Reason for that is because our chords are just taking the entire screen and reducing it to like a 0-1.
Right.
So what we actually need to do is sort of normalize that. And say, okay, well, and sort of make it like resolution dependent, I guess.
Okay.
So if you replace your frag coordinate divide by iResolution minus 0.5 with get screen space.
Just the entire thing?
Yep. So get screen space, camel case, yeah. And then, yeah, exactly, it's a function.
Cool.
So what this does is it does all of that. So if you were to do the same thing, you'll see it. Yeah, exactly.
Oh, that's fantastic.
Yeah.
So
that's we can talk through that a little bit. It's slightly more complicated, but
is that from 3JS?
No, so this is a function that I wrote.
Oh, okay. I was like, how in the world is it assuming?
Yeah.
Okay, got it. Okay, yeah. Let's talk through it super quick. I'm.
Yep.
Yeah.
So what this is doing, the first part of this, the first bracket, is taking the frag coord, and it's subtracting half the resolution.
That's why it's in center.
With vectors, you can just subtract other vectors from them, and it just works. So what we're doing here is we're multiplying iResolution by 0.5, which is the same as dividing it by 2.
Okay.
And subtracting that from the frag coord, so that centers everything. And then we're dividing it by either the resolution Y or the resolution X, whichever one is smaller.
Got it.
Yeah.
Why that bit? What's?
So that's the bit that makes it.
Okay.
That allows it to either sort of move into that space on the Y direction or the X direction.
It's right? Like a vmin.
Exactly.
Got it. Okay.
Yeah.
That makes sense. Awesome. That's a really handy, and that feels like one that once again we can add to our boilerplate.
Exactly. So that's in every single boilerplate for for stuff that I write for sure.
Great.
Yeah. Okay. So what should we do next? So one of the things that you can't really see at the moment is that the edge of that circle is really hairy. Because
I can see it. I don't think chat can, and the more I zoom in, the less I can't show it to you. But basically, this is where like what's that thing in video games where it like yes, thank you. Is it anti-aliasing or?
Anti-aliasing is the opposite. So anti-aliasing, what we're doing is we're sort of making the edge a little bit of a gradient so that it
right. That's what I'm thinking. Yeah. So like anti-aliasing is not on right now. It's very aliased, right? It's a hard pixelated steppy kind of line. Cool.
Mm-hmm. Yeah. So what we want to do here, there's another function in GLSL called smooth step. Smooth step does take 3 values. So what we want to feed this is for the first 2 values, we want to give it the points at which you form the gradient. So let's turn step into smooth step.
Okay.
All lowercase, all one word.
Okay.
Let's delete that 0.2.
Thank you for these follows, everyone. Great to have you on board.
And then the first 2 values should be those gradient values. So like in the first value, we'll put, let's say 0.2.
I think I hit insert on my thing. Cool. All right. So first value is 0.2.
Yep. Second value will be 0.99. and the third value will be your field.
Okay, so what are these?
Oh, sorry, 0.19 should be the second value.
Okay, so this is... Got it. Okay, it's just a little bit fuzzy. I don't know if chat can tell all that much, but if we make this like 4 and 3, 9, they'll be able to see it a bit more.
Sure.
I think they'll be able to see it.
Nope. So it's still fuzzy, right? Because what we're working with is values around that 0.4. So if you were to change that to 0.15 instead of 0.19.
0.15. Okay, got it. So
you'll be able to see it more.
Yeah, got it. It's more like a spotlight.
Yeah.
100 unsafe pages. Steve Gardner comes in. First thing he says is, "Save your pen." Thank you, Steve.
And then Steve's one of these guys that gets twitchy when he sees like photos of people's phone running out of battery. Or
he's the one commenting, "Charge your phone."
Yeah.
Thank you, Steve. Good to see you. That's awesome. Oh man. And thank you for the follow.
Yeah. So one of the things to play around with here is to maybe swap those values around and see what the difference is then.
Ooh. I'm guessing it's going to be a black circle with... Yeah, there we go.
Yeah, exactly.
Cool.
Yeah.
So just inverts it.
And so you want like anti-aliasing, which is like that really crisp transition. So if you just make that like 199, that should give you that.
Nice. All right. And yeah, that's much more crisp for sure. Awesome. Nice.
Okay.
So we got our circle.
Let's try something a little different. Let's maybe swap those around again. So 0.2, 0.199 field.
Almost there. Tried to be clever with it. Didn't work. We're good.
And in frag color, let's make that let's give that a color of, so let's maybe go coords X, Y, and 1 for the vec3 in there. So instead of mask, put coords.x, coords.y.
Oh, coords.x. Got it.
Yeah.
And then 1.
Yep. And then 1.
Ooh.
So that'll give us our gradient back here, which is great. But let's multiply that vec3. So if you put like a multiplication symbol next to that, then the mask.
Oh. Cool. We see a little bit of the gradient.
Yeah. So one of the things that you can do there to let's see it a little bit more. Let's around coords.x. Let's put a sine wave. So let's turn coords.x into a sine wave.
I'm sorry. I will. Just
yeah.
Adam, I think you can see chat, right?
I can.
I'll have a facial hair sink. Just because we trimmed together before the show, it's not weird, Adam. I don't know why you're coming in.
There's no need to be judgmental, Adam.
Yeah, man. Adam, next time you're on the show, sorry, but it's now the rules of the stream, so just be prepared. Cool. So you're saying a cosine or a sine?
A sine, yeah. So let's around coords.x, let's put a sine.
Okay.
So just type, it's a function. So sine.
SIN or SINE?
SIN.
Cool.
Yep. Okay. So not much has changed here.
Right.
But what we can do inside that sine function is add time as a component to x. So coords.x plus I time.
Okay. Starting to get a little bit mathy.
For sure.
I'm definitely not. Whoa. Okay. And just like that, we've got an animated gradient.
Exactly.
Holy crap. Okay. sine.
Yes.
I don't remember much since like college geometry, high school geometry. Whenever the last time I did that, I haven't used it since. What is
Hmm.
sine doing to this number?
Okay. So what the sine function does is it measures the y component of a circle. So given a value like this, what we're getting is a value between -1 and 1, which is it is the how do
Don't
I
sweat
describe
it
this?
if you can't off the top of your
No,
head
no, no.
perfectly define sine because
Yeah. So basically, what we're using sine for here is to describe a wave function,
got it.
right? So we know that sine gives us a value between 0 and 1 based on what our input
Sine.
is.
Right. So it's going to kind of keep going up smoothly and down smoothly. Like this is kind of
Exactly.
what we're expecting from sine.
Yeah,
Got it.
exactly. And so in this case, it's animating because we're giving we're adding coords.x and the time component together, and so it's just moving smoothly across.
Cool. Just so I can kind of understand more what sine is doing, can
Hmm.
we remove sine and keep the time bit just so I can see
What I
will
would
that
probably
work or no?
suggest first is removing the mask component. So if you remove that mask multiplication, and that way we just get a full screen of this.
Ah, cool, cool,
Sorry, no,
cool.
from
Right
the
there.
three. Yeah, exactly.
Cool. Yeah, that's really nice.
Right.
It's
So then if you just delete sine,
I can keep the parenthesis, right?
you can keep the parentheses, yeah, for sure.
Is it just going to take a lot longer or is
No,
it totally different?
it's because what's happening is your coords.x is now greater than 1, right? So it's clamping to that 1 value.
Got it. So sine is clamping. So sine is bringing everything down within 0 and 1 and also handling that animation bit.
Exactly. Yeah.
Got
So
it.
it creates this period, right, between -1 and 1.
Okay.
So you can also normalize that sine wave a little bit because any. Sorry, go on.
No. I think it's clicking with my brain. So
Mm,
if I can explain it and then you can fix the garbage I'm about to say, that'd be awesome.
sure.
So I time is continuously going up from 0 as soon as the shader loads in. Correct.
Hmm.
So it's going to go from 0 to infinite, right? Infinity. It's just going to keep ticking up. So that is pretty much this from 0, and it's just going to keep going and just go on. And along the way, we need to go between 1 and 0, and that's where sine's going to come through. So
Hmm.
as we go along, it's going to go up, and then it's going to come down. And time is the x-axis here, right?
Exactly. Yeah.
Got it. Okay.
Yeah.
So that's what it's handling. So it's taking this value, and depending on where we are in time and also the coordinate. So depending on where it is on screen, it's
Hmm.
going to get a value based on a sine wave.
Exactly. Yeah. So it's just
Got it.
creating a period for us to use,
Cool.
right? Yeah. Another way to create a period would be through like a modulo function, right? So if you know of that from your JavaScript,
Modulo,
um,
right?
yeah,
Okay,
exactly.
cool. I wasn't sure if it said
So a
modulo. Got
modulo
it.
just creates a periodic value between points that you set.
Cool.
Yeah.
You got people in the chat going ahead and making cool stuff without me. Wilster, that's not okay.
Nice.
That's not. That's awesome. Cool.
One of the things that you can do as well, because frag color is being clamped, all of your negative values are essentially discarded, right?
Okay.
So what you can do is you can normalize your sine wave between 0 and 1. And the way that you do that is you take that value and you divide it in half and you add 0.5.
So this value,
Mm-hmm.
so divided by 2 and
Yeah,
plus 0.5.
exactly.
0.5? Does it
Yeah.
matter?
0.5 works as well.
How did I break it?
Is that? Oh, your 2 is cast as an integer, so you just
Thank you. I'm going to do that
dot.
every time. I will be DMing you in like 3 days being, why is this broken? You'll go in and go 0.0, 0.0, 0.0 like 12 times. Okay, so how did this change?
So what this is doing is that red value is now clamped between 0 and 1 instead of -1 and 1. So what we're saying is divide the value in 2. So whenever it is -1, it becomes -0.5 instead. Right?
Okay.
And then we're adding 0.5 to that.
Got
which just
it.
brings it up to that level.
Got it. And Wilster, I was completely kidding. You don't have to apologize. I'm thrilled that you're working on it and playing around. That's the whole point here. I'm so glad that you are
absolutely the whole point.
Coding along with us. That's fantastic.
So one of the cool things we can do as well with chords.x is we can increase the frequency of the wave. Right?
Okay.
So if you think of that sine wave you were looking at before,
yeah,
increasing the frequency means like compressing it down.
Right.
Right.
Right. So having more frequent,
waves.
Yeah.
Exactly.
So this one's pretty spread out, where we're getting one wave like every 3 seconds or something. Mm-hmm. So how would we?
So you multiply chords.x by some factor.
5.0.
There you go.
I mean, I'm just staying on brand here. I'm staying on brand.
Yeah.
Cool. Okay, so time is it's still going to move at the same pace, but the waves are clearly tighter.
Yep.
Got it.
So you can increase the frequency of time as well.
Right. So you can go like
multiply time by 5 as well.
Oh, I did 3.5. I think you said the number 5, and that's where my finger went. Got it. So so that's increasing the pace of it moving. Right. Very cool.
Yeah.
All right.
So then, if you were to add your mask back to that vec3, then all of a sudden you'd have a circle with a gradient animating inside it.
So where do I do that? I multiply that at the end times mask.
After the vec3, yeah, exactly.
Or so before the 2 and the 0.5.
No, so one of the things that you can do here to make your life a bit easier is hit enter before the vec3.
Before the vec3.
So you can, because we've got these semicolons.
I was going to ask you how do we tidy this up, because it was getting a little.
There you go.
So here, go mask.
Times mask, exactly.
Nice.
There you go.
That's really cool. So mask is going to make it so that, just once again, anything out here, no matter what, is going to be black. And then everything in here can play ball, basically.
Yep. So it's multiplying the color that you've built by either 0 or 1, or that anti-alias value.
Okay, so 0 is going to clearly go to 0. 1 is going to stick it where it is already. It's just going to keep it.
Yeah.
Awesome.
Exactly. Yeah.
That's really cool.
All right.
Now, quick. Okay. So I was going to ask you a question of like, is this truly masking? It's not really, because we're still returning black. Like if there's something behind it, we wouldn't be able to see it, right? Because this is still painting black there. This isn't like the absence of color or the absence of a value. That's like truly painting black, right?
In this case, yeah. But if you were to multiply your entire vec4 by that mask instead of just the RGB component, then it would be masking.
Cool. Oh yeah. Because we've got the alpha right here. That makes sense.
Exactly. Yeah.
Cool. And if we did it now, we wouldn't see it because black is kind of the default, right?
I'm not sure whether 3GS has pre-multiplied alpha turned on, but you could try it.
All right. And Jack, thank you so much for those bits. That's super generous. He says, great to see behind the curtain of the shader in Vader. Liam, thanks for sharing the knowledge. Jack, thank you so much. Yeah, I'm thrilled to have you on, Liam, because I mean, I've never called you the shader invader, but I think that's gonna stick. I like it. I like it.
I hope not.
All right, you heard it here, folks. I guess you could just put mask, right? You don't need to do 1 times mask. but that should have been the same result. Yeah, so it seems like the background's black, as a
yeah.
default. Cool.
Yeah, so what you need to do is turn alpha onto your
cool.
in the 3GS code, which you can
Yeah,
do.
no worries. I was just curious. Cool.
Yeah. Yeah.
All right.
Cool. So let's maybe talk about some other shapes. So creating oblongs is not too far removed from this.
Okay.
So maybe let's start there. If you could probably fork this, maybe, or
Cool.
we could just comment this stuff out, whatever you want.
Yeah. Now, what do you mean by oblongs? Just like square based shapes? Is that what you mean?
Yeah.
Like
a square is an
a
oblong,
long
but not
rectangle.
all oblongs are square. Yeah, exactly.
Okay. Cool.
Yeah.
Circle shader. And I'll fork this.
I always forget that you can edit the title up there. I always go to settings to edit the title.
Oh, got it. Yeah. No, I always do that there. I forgot that you could do it in settings. Cool. So we got circle shader, and now this is oblong shader. All right, cool.
Yeah. So what we're gonna do here? Let's get rid of. Actually, let's turn mask. We'll make that into a 1 instead. So for right now, let's just replace smooth step with a 1 value.
Cool. Yeah. So that should give us the whole
1.
gradient, right? No? Does it?
1.0.
Oh.
It's all good.
Oh, man.
Yeah, so that just gives you the gradient.
Yeah, cool.
So what you can do here instead is let's use a step for right now just because it's easier. So let's make mask a step.
Okay.
And we'll make that a step of the coord.x value. Yeah. And then for right now, let's just put a 0 in the second parameter.
All right.
Yeah.
So it should give us nothing or everything?
0.0.
Oh, man.
Why is that not working? Coords.
Ah, thank you.
Yeah.
Missing yes. Thank you, Daniel Cruz. And thank you for that follow. Appreciate it. Welcome. Okay. Oh. Okay. So last time we were passing
Last time we were passing a length in there.
Yeah, so that was looking at all the axes, but this is just looking at the x. So as soon as x hits, and we're also starting from the center.
Yep.
So as soon as it goes below 0, we can see it. Is that?
Yeah, exactly.
Got
it. Because everything on the left side of the screen is negative value. You're getting a 1 for that.
Yeah, Andy, that's exactly right. Andy just said he wasn't here for a sec. Now the origin's in the middle. That's exactly right, Andy.
Yeah, exactly. So we can construct this in a number of ways. Let's start by the most obvious, which is saying, okay, well, let's extend that step out to 0.3.
This right here?
Yeah, exactly.
Cool.
Right, so that's going to move that line over to the right a little bit.
Right.
Then let's multiply that. So outside of that, so step times, and then we'll create another step here.
Interesting. Okay.
And what we want to do this time around is we want the first value to be negative 0.3.
Okay.
And the second value to be the coords.x.
I can't even predict what this is going to do. Well,
okay, so let's step through this a little bit.
Oh, okay, yeah.
Right, because everywhere that the left value is less than the right value, you're getting a 1.
Got it. Yeah, I had a bad mental model where step takes first like coordinates and then the value that you want those to be less than, but it just takes two values, period, and returns a Boolean response.
Exactly. Yeah.
Got it.
Often in shaders, you use step to create booleans.
Got
Essentially,
it.
you multiply a value by a step, and then you get a positive or a negative response.
Got it. So it takes
Yeah.
like to basically A and B, and if A is greater than B, it's true, or if A is less
Mm-hmm.
than B. If the first is less than or greater than the second one.
If the first is less than.
Okay, cool.
Yeah.
Then it's okay. Then it returns
Yeah.
a 1, otherwise it's a 0.
Yeah.
Got it. Okay.
Yeah.
That makes complete sense to me then now. Cool.
Okay. There is an easier way to do this.
Okay.
But it's a bit more of a logical leap.
Okay.
So what I tend to like to do with this is in a lot of shader programming, you'll see people taking advantage or looking for ways to take advantage of symmetries. So let's do that here, and we're gonna replace. Let's comment out that mask, and we'll create a new mask value.
Okay.
Just for comparison's sake.
Cool. Is there like absolute values or something that we can do here, or like?
Yeah, exactly. So
Okay.
those are exactly the sort of symmetries that we want to take advantage of. So if you do float mask equals, and we'll turn it into a smooth step just because we know how to use that now.
Nice.
Yeah. And let's make that. Let's make the first value 0.3 and the second value 0.29. And then the third value can just be coords.x again. So we'll see what that looks like.
Should be, yep. Back to the first. Got it.
Exactly. So if you want to wrap that coords.x in an abs,
cool. So this makes it so that as we're coming out from the origin in either direction, did I do that wrong? Yes, it ate my second parenthesis. As we're coming out, so as it's going to the right, it's going 1, 2, 3, 4, 5, and as you're going to the left, it would normally go -1, -2, -3, but because of the absolute, it's going 1, 2, 3, 4, 5, and as soon as it gets out past our 0.29 and 0.3, it just goes black.
Exactly.
That's really handy.
Yeah. So one of the reasons that in shader programming you want to take advantage of these sort of symmetries wherever you can, is because it drastically simplifies the amount of computations the shader needs to run for every pixel again.
Got it.
So then what we can do is we can repeat the same step that we did above. So if you go onto a new line, it's probably easier to read. And then mask times equals. And then you can just copy and paste that smooth step and replace the X with a Y.
Oh, okay, cool.
Yeah.
Chords Y. Nice. Okay. So that
Right.
so is this like the typical way that you would make a square if you wanted to?
Yeah, I'm going to get a little bit more advanced here because
Okay.
I feel like it's kind of an important concept to get across. So
Great.
what we're currently using is we're using the first two values to define the width and the height, right?
Right.
And changing those gets a little bit convoluted, right? So if we wanted to make it narrower, for example, you would maybe turn that first one into 0.2 and 0.19.
Cool. So 0.2 and 0.19 is what you're saying?
Yeah. So that's sort of the obvious way to make this like a narrower.
Right.
Oh, right. Yeah.
But kind of a pain in the butt to actually like keep changing those, right?
Exactly. So what I would normally do is I would make both smooth steps between, let's say, 0.01 and 0.
0.01 and 0. That's what you're saying? Okay.
Yep, for both of them.
And then do we
So that gives
multiply
us
that out by a number?
No, what I do here, because we're getting the abs value,
Right.
what we can do from there is subtract a value. So on your first one, after the abs, let's subtract 0.2 from that.
Okay.
And so what this is doing is it's taking that absolute value and it's simply moving it across.
Got it. I
Right?
think. Okay, so yeah.
This is not a super simple concept to get, but it is a really valuable one to play around with. And you can do this then the same thing for Y.
Okay, cool.
Yeah.
And Gene, thank you for being here. Take care. And good to see you, 8070. Welcome back.
See you soon.
Cool. Okay. So that just pulls out the coordinates a bit closer to the edge, or it pulls out the value that we're pulling from that. Got
exactly. So all of a sudden, if you wanted that to be taller, you could replace that second 0.2 with a 0.3 or something.
Got it. Okay. Yeah. So instead of going through and finagling with these really, just more touchy values and changing those in two places, I have just one handle that's a lot easier to play with.
Exactly.
That's really cool.
Yeah. So one good way to sort of abstract this out a little more is above that mask, let's create another vec2 called dimensions.
Like that?
Yep. And then in that, we'll create a vec2 with a 0.2 value and a 0.4 value.
0.2, 0.4. Cool. And then we can use that instead, right?
Exactly.
Got it.
Not in there.
Oh, not in there. Sorry.
Use it as the subtraction.
Oh, okay. So do we go dimensions.x?
Minus dimensions.x. Yeah, exactly.
Got it. That is handy.
Yeah.
Y, right?
Yeah, exactly.
Nice. Okay, so now this is the dimensions of our shape.
That's exactly right.
Cool.
Yeah. So all of a sudden you start to see here how you can abstract a square out into a function.
Got it. But
right? Some reusable function that takes.
Yeah, I was just gonna say I'm also seeing just how, like, if you're used to working with something like Three.js or like SVG, where you can just like say, I want a circle type, I want a rectangle type, right? Like the fact that we're making rectangles and circles through mathematics is really interesting, and definitely a mindset shift for me. Mm-hmm. Where, like, with SVG, it's like, how do you make a rectangle? Just rect, right? Like rect, you give it the points, you're good to go. This is really interesting, just how much goes into it, but the benefits,
right? Exactly,
that you can get from it. Like yes, it's a bit more upfront work, for sure. But what you can do with this once you've like gotten past these like initial, like it's just the onboarding to shader proficiency feels a lot steeper than something like SVG, where it's like, here's the basic shapes, put them where you want, it'll show up where you want, and you just assign it a fill, right? And you've got a rectangle. Where this it's more complicated, but man, do you have like a powerful thing once you kind of get the hang of that.
Right, you've got this sort of super powerful palette to play with all of a sudden.
Right.
And you're right, like it does feel like a lot of more work up front, but it's all this sort of just incremental knowledge. And it's one thing that Book of Shaders, which was mentioned before, is really good at, is sort of ramping up that complexity in a way that's pretty, it's a pretty easy gradient.
It's digestible.
Exactly.
Bit by bit.
Yeah.
Cool.
Yeah. What I'm going to do here now, we're going to do something that's going to hopefully be really cool and surprising, but isn't going to make a lot of sense while we're writing it. So,
okay.
Above dimensions,
all right.
Let's say coords.x plus equals. Let's make a sine wave. So sine coords.y. And then we'll multiply the sine wave by like 0.2.
Okay.
Yep.
Oh.
Let's multiply coords.y by 20.
Inside here?
Mm-hmm. Float.
Damn it. One of these times I'm going to put the little circle. Damn it. Okay. Okay, so we've tightened. So we're using a sine wave.
Yeah.
We've really tightened those up. And are we lying about what the coordinates are? So we've gotten the coordinates here from screen space, and then we like mess with them.
Exactly.
Yeah. And we kind of lie and we say this is 0.3 when it's actually 0 or something, right? Because of the sine wave. That's wild.
Yeah.
That's really fun. And even the gradients coming in, like with the wave. I thought just the mask was affected, but everything's affected. We've essentially,
because from that point on, that's what coords.x
that's
is,
what
right?
it. Yeah, that makes a lot of sense.
Yeah.
Steve is here to help me. He says you should add console.error. You missed 0.0 probably to the top. Honestly, when I start getting into shaders, that's just going to be like a post-it note on my screen.
So Steve is a guy that's probably pretty familiar with shaders at this point, given all of the 3D stuff that he does. I would like to know how long it took him to get used to the fact that you have to put points after floats.
Yeah, Steve, how long did it take you? Cool. This is wild.
Right, exactly. So you can see how you can just start to mess with this, and just how powerful, like, sure, creating an oblong is quite complicated and difficult, but all of a sudden you can just add this one line that just does this.
Right. Like, as I was just saying, like, did it take, a lot more code, a bit more math, whatever, to create a rectangle than with SVG? Yeah, absolutely. If you had to have a rectangle done ASAP, I might not go for a shader, right? But if someone hands you like, hey, I need a gradient that does this neat wavy effect, good luck. I mean, I guess you can do this SVG, but not the same way. It's the comparison to SVG doesn't actually make sense because they're very different things. They're both great at different things. I don't mean to say like SVG's dead, shaders, but no, this is really cool.
So maybe try adding the time component inside that sine wave as well.
So plus I time?
Yeah, exactly.
Oh, it's gonna move, isn't it?
Yeah.
Nice. And because it's the sine wave, it's seamless and it's gonna match up the whole time, right? Like it's gonna.
Exactly. Yeah.
That's really nice. That's one real benefit to using like sine waves and cosine, all those, just because they loop perfectly, right? Like they come back on themselves perfectly.
Yep. It's this great sort of periodicity.
Yeah, that's really fun, Liam. Wow. Awesome.
Okay. I feel like next, I was going to get into other shapes, but I feel like maybe what we kind of want to do at this point, we can extend on this. And what I want to talk about is one of the real benefits of shader programming and fragment shader programming, which is this sort of concept of infinity. Right?
Okay.
So what we're going to do, let's delete that first frag color up on line 16.
Okay, just wipe it out.
Yeah, exactly. So the first thing we want to do is zoom out a little bit. So let's multiply coords by 5, let's say.
Coords plus equals. Oh.
Times equals.
Yeah, sorry.
Yeah.
Times equals 5.0.
Yeah, exactly.
Got it. I got it. First,
Nice. You
and
got
yeah,
it. You got it.
Adrian says lava lamp vibes. Totally agree.
100%. Yeah.
Yeah, that's cool.
Yeah. You very quickly sort of dive into the psychedelic when you first start programming
It
shaders
seems
just
hard
because of
to
this, right?
avoid. Yeah.
It really is for sure. Okay, so we've zoomed out a bit. This is great. What we want to do at this point is take those coordinates and repeat them, right?
Oh.
So under that, what we want to do is say coords equals, and there's a function in GLSL called fract. So FRACT,
Okay.
coords. So what this is giving us is the fractional component of the coordinates, which
What in the
is,
world?
so what we've done is we've multiplied the coordinates by 5, which takes them all the way out, sort of greater than 1 numbers. And what we're doing with fract is taking all of those extra numbers and reducing them to a 0 or a 1. Like, or that space between 0 and 1.
Okay, so coordinates is going so from the center,
Mm-hmm.
right? We are going out from like 0. Wait, so is this 0 here in the center and then we go out to 1, so these are all floats, or is this like 1 pixel, 2 pixel, 3? What's my unit here? Is the side here like 5,000, or is it 1?
So this is why normally like UV or P is used as this value, because it sort of represents, rather than an exact position on screen, it represents sort of an imagination of where that is. It's a unitless
Got it. Right.
value
Right.
essentially.
But is
Yeah.
is that number greater than 1 out there, or is the edge 1?
So let's remove both of the lines 16 and 17. Just
Okay.
comment those out for a sec. So currently, the values are normalized to between 0 in the middle and 0.5, let's say, on the right-hand edge. So let's
Right,
just
that's
talk
what it
about
was.
x coordinates at the moment,
Got it. Okay, cool.
right? And what
So
we're doing with line 16 is we're taking that value and multiplying it by 5. So all of a sudden, a value that was, let's say, 0.5 is now 2.5.
okay.
Right? So
Yeah.
because we're drawing shapes within this range that we've defined with our dimensions, so if you uncomment line 16,
Right.
our dimensions are saying, okay, well, that oblong is, 0.2 units or 0.4 units wide, essentially, right?
Got it.
And now because those values are so much greater, it's drawing it smaller. So multiplying those coordinates could be likened to zooming out if we're
Got it.
thinking of a
Because
virtual camera.
we basically said, hey, only show it if it's beyond this kind of a range,
Mm-hmm.
and now we're kind of lying about what this coordinate is. So we're saying this is way bigger than what you want. This is a really big number, and so it goes, okay, got it. So I'm looking for the numbers in here then, and it's doing it there.
Yeah, exactly.
Got it. So
Yeah.
so that zooms us out by saying those numbers are huge. Now fract does how does fract know, like this part I'm not getting what fract is doing.
So yeah, let's talk about this. So one of the things maybe to make this clearer
Yeah.
is let's subtract 0.5 from that fract.
Okay. Whoa. Okay, but why?
Okay.
Yeah.
So what fract is doing is it's taking those values that you supplied it, and where those values, it's giving you the fractional component. So it's saying if the number is 0.5, then return 0.5. If it's 1.5, still return 0.5. So it's basically chopping the front off that number and just giving you the fraction.
Cool.
Right. So what it is doing with those values that are greater than 5 is it's compressing them down into the coordinate space that you're drawing your square into.
Okay.
Right? And because we're sort of doing this, we're drawing this square in this way, all of a sudden, all of the values that are at 0.5 will be drawn as if they're at 0.5. So it just repeats the same thing.
Got it. Okay. So it's a nice way to make repeatable patterns without having to pack a whole bunch into these other bits, right? Like, so like I can make just kind of the part of the pattern that I like, and then I can work with, I can zoom out on it and use fract and then kind of dial this number in at the right spot in order to make them line up seamlessly and go from there. Although it seems like it might be tough to line them up seamlessly, unless that's just, I don't know.
So what you need to do is define the period of that sine wave such that it matched exactly the coordinate space
That makes sense.
talking about, right? Yeah, yeah.
So at the top and the bottom start and stop at the same spot.
Exactly.
Got it. Cool.
Okay, so let's do something else here, and above where you've multiplied coordinates by 5, so above line 16, let's say coords.x plus equals I time. This is probably going to move really quickly.
Whoa.
Right.
That's
so
wild.
Multiply I time by like 0.2 or something like that.
Cool. Okay, so we can now say essentially the coordinates for x are constantly moving. They're constantly getting bigger.
Exactly.
So whatever the UV is, we're going to add it by the current time.
Exactly.
Cool.
Yeah. So let's maybe comment that out.
Sorry, I'm kind of
Totally cool.
Getting lost at it. Wow. Comment out the time thing that we just did?
Yeah, exactly.
Cool.
So what we're going to do now is we're going to talk about randomness.
Okay.
GLSL does not have a random function. So you need to create it yourself somehow. The way that I do that is I use a texture. It's in sort of graphics terminology, it's called a LUT, so a lookup texture.
Okay.
Right. So let's say, actually, let's start with the ID of each cell. So let's call these cells.
So 1 cell, 2 cell, right? Like, so there are different cells. Cool.
Yeah. So let's create a new vec2 called ID.
Right here?
Yeah, exactly.
Vec2 ID equals.
And what this will be is the floor of the coordinates value. Actually, this needs to go after the multiplication.
Cool.
Yeah. So the floor of coords.
Okay.
So what this ID now contains, if you consider the cell at the beginning to be the origin, then that cell's ID is going to be 0, 0. The one immediately to its right will be 0, 1. The one to the right of that will be 0, 2, stuff like that, right?
Got it. Because, okay. So as you said, like it used to be 0.5, but now it's going to be like 2.5.
Mm-hmm.
So that'll just round down to 2, and so on and so on. Got it. Okay.
Yeah, exactly. So one thing that we can do immediately with this is let's, underneath that ID, let's do the same thing we did before. So coords.x plus equals I time times ID.y. Hopefully that works. Yeah.
What?
Okay, so let's talk through this quickly. So because we've got their cell IDs and those cell IDs are two-dimensional, what we're
Right.
saying is add the time component to that multiplied by whatever the cell's YID component is.
Got it. And so just so it clicked for me just now. We don't need to like for loop through or anything because that's essentially we're kind of inside a for loop at all times, right? Like
Yeah.
right now, we this ID is whatever like pixel we are like the ID is getting found out on itself, and then we are getting a different speed
Mm-hmm.
based on which row it's in. So yeah, sorry. I'm just like, how the heck did we do that?
No, exactly.
It's
Yeah.
because main is being called on every single pixel on my screen,
Mm-hmm.
and that's kind of the for loop apparatus that's already happening, right? And so
Exactly.
this is all happening inside, and we're able to figure out where it is because of this,
Mm-hmm.
and adjust the speed depending on where it is on our screen. That's freaking cool. And yeah, Adrian, add a frog and help it cross the canvas from the bottom to the top. That's pretty spot on. Yeah, this is like Frogger on shrooms or acid or whatever the joke is. I don't know, but yeah, that's really funny.
So speaking of games, there are people who write games just in this language, which is
Really?
absolutely insane. If you go to ShaderToy and search for games, you'll come up with a whole bunch. It's crazy what people write in this shit.
Wow.
Yeah.
Yeah, this is cool.
Yeah. Okay, so you can see that as we sort of go upwards in the browser, that things are going to the left, and that's because those are negative values.
Right.
And as we're going down, those are positive values,
And then
right?
this just doesn't move because
Yeah,
it's
exactly. Because
just at
it's
the origin,
zero.
right?
Yeah, exactly.
Cool.
So let's get a random value.
Right.
Okay. So above above that line you've just made, so below line 18.
Below line 18. Cool.
Yeah. Let's create a float called random. And what we're going to populate this with is a value from the texture that we loaded earlier,
Right.
right? So actually, do you want to just open that texture up in
Yeah.
a browser window and we can see what that
It's
looks
in the
like?
JavaScript, right?
Yeah, exactly.
Are we gonna pull like from the same ID or something that we're? Yeah, I'm trying to think how you're gonna do this because this is kind of what I'm expecting. I'm expecting we're gonna grab a pixel from here and use that as a random value because this is essentially a random texture. I'm trying to think of how you're getting
Mm-hmm.
a different one each time. So I don't know. This is really interesting.
For sure, yeah. So if you go back to the
Cool.
shader, and what we want to do is there's a function called texture2D.
In this.
Sorry, in your yeah, exactly. Yeah.
Oh, cool.
So for your random value, what we
Float
want to do
random.
is equals texture2D.
It's like that.
2D, yeah,
Capital D. Cool.
Yeah. The first parameter for that is the texture uniform, so I think it's iNoise, right?
Let's just check
yeah,
to make sure. iNoise.
Yeah.
That was the original name for the iPod, by the way. They changed it last minute.
And then the second value will be a vec2, which will correspond to the coordinate, the normalized coordinate on that you want to sample. So what we want to do is...
So, coords?
No, yeah, coords.y for both values.
Okay. It's like that?
Mm-hmm.
Cool.
Yep. No, the second value should be a y as well.
Oh, they're both y.
Yeah, and I'll show you why in a sec.
Why did that break it?
So that's broken because texture2D returns a vec4. So what we want to do there is after that texture2D call, we just want to add .x.
Got it.
So another good point here, something that's kind of useful. Vec4s will have X, Y, Z, and W components, but they will also have R, G, B, and A components, which correspond to the same thing. They're aliases of each other. So you could replace that X with an R, and it would still work the same way.
That's cool. Okay.
Yeah. Useful thing.
Yeah.
So then we want to replace in the coords.x, that itime component, we want to replace id.y with the random value.
Okay. Random.y, or no, it's already pulling off that x, so it should just be one dot.
It's just a float.
Whoa!
Yeah, exactly.
What in the world?
Okay. So, can you guess why that's happening?
I need to figure this out. Okay, hold on. So we get texture 2D, we load our texture in, and then we're picking a specific pixel here, right?
Mm-hmm.
So because coordinates are being set, so it's basically pulling off the texture from there. It's grabbing the red value of this, right? So yeah, it's finding. I'm trying to think. Why is it? Why are we doing y? I'm not sure, but we're getting the red value of one of these pixels from here. I just can't figure out how we're getting the exact spot.
Okay, so let's change coords.y to id.y.
In both spots?
Yeah, exactly.
Did I do it wrong?
No. But I feel like what we need to do is maybe multiply that id.y by like 8 or something like that.
In both?
Yeah, exactly.
8.0, you mean, Liam?
Exactly.
Right. Sorry, I only recognize floats around here.
Why is that not working? Text 2D.
It's totally fine if you want to keep just rolling with the other one. I didn't mean to derail. That was just
no. It's all good. So what we're trying to do here is get a different random value for each row, right?
Right.
Let me try this.
Jayuk says, "Can you multiply entire vector by a scalar or a scalar?"
So let's do that. Let's simplify the vector that you've got here.
Okay.
So let's replace that whole vector with id.y.
So vec2.
No.
Oh.
So just id.
id.y.
.y. Yeah. So 2 y's.
.y.
Yeah. So no. .yy. So in the same way, and I'll explain this really quick. In the same way that we used xy before to just get the x and y components, you can use yy. You can mix them up in any way that you want.
Could I do YYY for like a vec3?
For a vec3, yeah, exactly.
That's cool. All right.
Yeah.
That's really neat.
So then let's maybe just try multiplying this by a really high number, like 256.
Times 256. 50 Ubby Bunny said, "Oh, thank you, Adrian." Yeah, so we're using 3 just to apply this shader to a plane. So it's a very small amount of 3JS. It's just to kind of get it in the scene, and then we're going from there with GLSL.
256.
Of course. Damn it! I got so cocky.
Yeah, you did. Okay, I don't know why this is not working.
It's fine. Let's just go back to the bit that was working, because it was working real cool. That's wild. So yeah, so it's giving us so it's like not. I mean, there's no true random in computing, I know, but this is like less than that still, right? It's still coming from like a very finite set of things, right?
Yeah, exactly.
But still, the closest that you can kind of get with this sort of stuff, right?
Yeah. Cool. So there's a whole bunch of functions that you can use to get random values or pseudo-random values.
Cool.
Another one is to like create a sine wave, which is super high and super compressed.
Okay.
And then just pick a value in that, and it's it's like a sort of pseudo random value. So Book of Shaders goes into that a bit as well.
Nice. Okay, cool.
This is more performant. This is why I like to use it. So
awesome.
Yeah, I wish I knew why that wasn't working.
That's fine.
Yeah. Cool. Okay. So what should we do next?
I don't know. We've got like a couple minutes. Do you want to kind of I would love to know, although it might be, you know, like I feel like if I kind of sat and hacked at it for a while, I might be able to figure it out. But kind of going back to that initial like rainbow gradient that you had, that might be super simple, but it's just like really satisfying. I don't know.
Sure.
Or I mean, that was just my thought process, but I haven't been able to think of any of this stuff, so I'm not going to tell you what cool ideas we should do.
We can totally do that.
So we can save this and fork it and just go.
Yeah, exactly.
Finish with a rainbow.
Finish with a rainbow.
Kind of going back to the initial template. It doesn't have to be like exactly that.
That's fine.
But just
so let's gut what we've done here.
Let's get rid of screen space.
Keep screen space. Yeah, exactly.
Everything else can go.
Everything else can go. Let's start from scratch actually, just for people who joined late maybe.
Cool. Should we cut it down to this?
No,
or?
That's fine. I think that's
cool.
That's probably a good place to start. So we've got our coordinates.
Yeah.
And let's set our frag color to the coordinates.
So frag color equals.
It's GL frag color. Oh no, sorry. Yeah, we're passing it as frag color. My bad.
Cool. As coords .xy or no?
So it needs to be a vec4.
Right. So that, and then
if you pass, let's try passing coords in there twice.
That?
Yeah. Let's see what that does.
That's pretty cool.
Cool. Okay. So above that, below line 15, let's turn coords into a sine wave. So coords equals sine coords. Okay. Let's maybe multiply that.
Inside or outside?
Inside. So we'll increase the frequency a little.
By what?
2. Let's start with something modest.
Okay.
Okay, and then maybe let's add a time component to that as well.
Yeah, and for people who did come in recently, oh, that's so neat. Okay. We are passing that time in as uniforms here. What's actually telling it to increment time?
If you scroll down to the request animation frame.
Got it. It's ticking up.
It is.
Where is that request?
Right there.
Did I miss it?
So no, above that.
Animation. This?
Yeah.
Got it. Okay. So cool. It's just taking the time, multiplying by that. Awesome.
Yeah. You can increase that or decrease it. Like if you increase that multiplication to like 0.1 or something.
It'll go way faster?
Yeah, way faster.
Okay. Oh, sorry. Sorry for anyone. Shit. That's
sorry. Yeah.
All good.
My bad there.
No, it's all good. Apologies if cool. So yeah, definitely seizure warning. All right.
Sorry,
so
I didn't think it'd be that bad.
Yeah, no. I know you weren't trying to do a flashing light thing. Cool. So okay, back to
actually
this.
let's do something really quickly here.
Yeah.
So let's in those coords multiply them by 0.5 and add 0.5.
Wait, where?
Sorry, in the shape.
Up here. Cool.
Yeah.
All right.
So after the sine.
Okay.
Yeah. Times 0.5.
Times equals point. Oh, got it. Sorry. Times 0.5.
Yeah. And plus add 0.5.
Interesting.
So this is normalizing it in that way that we were talking about before, just bringing it up to that range between 0 and 1 instead of -0 and 1.
Got it. This is, I'm already kind of seeing where we're going. This is really cool.
Let's add a little bit of noise to it as well.
Okay.
So after the vec4, just type plus.
After the vec4, where's that?
So on
Here,
line
got
18.
it.
Yeah.
Plus.
Yeah. Texture 2D. And then the iNoise. And then just use the chords.
And so that's going to say, whoa.
So what you probably want to do is just multiply that, the value coming out of that by like 0.1 or something like that, just to make it a bit more subtle.
Yeah. Why is it getting warped at the edges like that? It's the actual...
It's because of the sine wave, right?
Oh. So because the sine wave, like, as we go along, the value's changing a whole lot here. So that's where we're not getting that warping. But then it packs in, and like 30 values in a row are the same or very close to the same value.
Yeah, exactly.
And then it comes back out and kind of starts to move fast again. It kind of packs in at the peak. And so these are the peaks and the valleys right there. Got it. That's, I can kind of see it now.
You start to visualize it, right?
Yeah, for sure.
So what we can do instead of that, let's, below line 15, let's just create a copy of that vector. So let's call it O coords or something like that.
Okay. So vec2? Or
we want to do it above that line.
Got it.
Yeah.
So what is it going to be? A vec2?
Yep, vec2.
O coords?
Yeah, something like that. And then just equals coords.
Got it.
And then let's use those as the coordinates for the texture.
And so that it's not getting like mutated by the sine wave.
Exactly. Yeah.
So it's just going to stay flat because. Cool. And so the sine wave is also moving it because the sine wave is, or the chords are being mutated by sine wave and by time. These O chords before that, they're not changing from either of those. So we're just getting that wash over. What's, I'm trying to figure out why it feels like it has a blend mode applied to it. It's kind of what my brain's trying to wrap around.
So it's because we're taking that noise texture and we're stretching it, right? So what we want to do instead, let's multiply O chords by 2,
okay,
for example, and that'll sort of compress that noise a little.
I'm not sure if that's what it is for me though. It just feels like we're applying like a multiply or an overlay.
Oh, I see.
Mode.
It's because we're adding that.
It's additive, so it kind of is a blend mode, honestly.
Exactly.
Yeah. Okay.
So, and that's, you also sort of start to get a sense of what those blend modes.
How blend modes actually work, right? Because to me,
that's right.
You know, it's just been like clicking. Like I kind of understand like multiplies for dark things, lights for light things, right? But I don't have that like mathematical understanding. There's actual math under the hood of each of those blend modes.
Absolutely, there is. Yeah.
Neat.
So
okay.
What you can do is actually wrap that texture 2D in parentheses.
Okay. Along with this or just this?
Along with the times 0.1. Yeah.
We're about to get rated by Learn with Jason. Very cool. Thank you, Ben. Well, Jason, thank you for that raid again. 2 days in a row. I can't thank you enough. We're making shaders, everybody. We've got some really cool stuff going on. Liam Egan, my guest, fantastic shader master shade. I mean, he was called the shader invader by guests earlier. That's gonna stick. We're gonna make that stick. He is from We the Collective, but CodePen SHUB. Yeah, there we go. Yeah. So I just want to show off your CodePen super quick. We're making all kinds of shaders. We're doing lots of fun stuff. Yeah. So if you're not familiar with shaders, welcome. You're in the right place. I have learned all of that today. Liam is our resident expert. But basically, this is the kind of stuff that you can do with shaders. This is a 100% shader work. Is that accurate,
Yeah, that's
Liam?
right. Yep.
Like there's not actual like 3JS geometry here. Like this is shaders.
Yeah. So this is using a technique called ray marching and I'll describe that really briefly. So
Yeah.
what we're doing for each pixel is we're shooting a ray out of it and measuring how far from the nearest object it is, and then marching along that ray by that distance until it finally hits something, and then we render like the walls and stuff like that.
It's so freaking cool. Yeah, like just it feels like a video game, and it's accurate because shaders are used in video games. Shaders are used on everything from like the Stripe homepage to your favorite video game uses shaders. And sorry, I'm talking to the crowd. I know you know this, Liam. Sorry. But yeah, so like shaders are super versatile. You can use them in Blender. You can use them pretty much anywhere that you're doing any kind of 3D stuff. And we're learning them because they're freaking cool. And some of the stuff that we're doing, like right now, we're kind of doing our own like a very simple version of like the Stripe homepage. This is a shader. It's these like nice gradients flowing together. And yeah, that's a shader, and we're kind of learning how to make something like that. We've made a couple. Let me actually see if I can just grab those, and then we'll dip right back into it. I just want to make sure that
for sure.
that they're caught up. Oh, we made some cool ones. Did I save them? Okay, so the circle shader was the first one we made, and then we had the oblong shader. Yeah, so we made this, and then this is like a noisy version. We'd make it. Wait, how do we get rid of the random?
Just remove remove the chords.x. So line
chords.x. Cool.
Yeah.
Yeah, lots of just cool stuff. We've been playing around with this a whole bunch, but yeah. So just want to catch you up real quick. Thank you again for that raid, Jason. Really appreciate it. Yes, and in it is GLSL is the language. So Brittany, that was another thing where I'm like, whoa, that's another kind of thing to learn. But the way Liam's been explaining it has definitely made it click a lot more. It's been an awesome episode. All we're using 3JS for is to basically create a plane, which is kind of like a piece of paper, and then we're drawing on it, and that's pretty much the most that we're doing with 3JS. Is just my understanding, Liam, is that it's like the easiest way to get shaders kind of quickly into the DOM, right?
Yeah, absolutely. Everyone's sort of passingly familiar with 3JS, so it's a really sort of good way to just boilerplate this stuff. There's so many frameworks out here that do this in a more in a quicker and easier way, but 3JS is just something people are familiar with.
Gotcha. And Brittany says it looks like Java. Java's pretty strongly typed too, right? Is that?
Yeah.
Cool. Yeah. So it has that similarity, Brittany. Good eye. Cool. So we were working towards that kind of like rainbow gradient thing. Let's finish on that.
For sure. Yeah, so let's take that parentheses and wrap it around the 0.1. So you want texture 2D times 0.1 inside parentheses.
Cool.
Yeah, exactly. So what we want to do then, we want to subtract 0.05 rather.
Oh, I'm so sorry to interrupt, Liam. We just got raided by someone else. We got Provod. Thank you for this raid. My goodness, we have a whole bunch of people in chat now. Chat from Provod. I'm stuttering on my words. We just got raided like two minutes ago, so I apologize if I'm like, whoa. Fantastic to have you, Provod. Yeah, shout out to Provod, SOPROVOD. Provod, thank you so much for that raid. We're doing some fantastic shader stuff here. I'm gonna super quick run through it because I'm sorry, sure. I just ran through it, friends of Provod. But you are welcome here. We do all kinds of creative coding here. This is like a very front of the front end kind of content. We do lots of creative development. Liam here is a creative developer head over at We the Collective. Yeah, we're always doing creative front end stuff here, so you are absolutely welcome. And we just made a couple of cool shaders. We started from scratch. It's like our intro to shaders. I don't know anything about shaders before today. And we made this. We learned how to make a circle and how to make some gradients and stuff. And then we went on to make this thing with sine waves and all kinds of cool tricks. And yeah, Liam does all kinds of cool shaders. He is our guest. And yeah, so like we were just talking about this one, how this is just shaders. This is just math. This is all math. This isn't a thing that he went through and designed the polygons of in Blender. This is 100% math. So we're learning shaders today. Tomorrow we're learning 11T. So if you're into web development, front-end web development, creative coding at all, follow. This is the place for you. So yeah, we are working towards a kind of rainbowy sort of thing. There's a lot going on here. Like, as you can see, like those sine waves kind of come in, right? This is more complex than meets the eye, right, Liam?
Mm-hmm. Yeah.
But we're gonna make kind of a simple rainbow gradient shader just to kind of finish off the day. But yeah, really appreciate the raids. Thank you so much. Cool. All right, so unless we get raided again, which, hey, more friends the better. Thank you so much for the raids. I appreciate it so much. We are going to finish this out. So we put the parentheses around. Cool.
Yep. And then we just want to subtract 0.5 from that 0.05 from that as well.
From inside or outside the parentheses?
Inside the parentheses.
Inside. So minus 0.05?
Yep.
Cool.
That just sort of normalizes that noise a little bit, so it brings it like back into sort of a range that doesn't make it look so additive, doesn't sort of
got it
everything out.
Okay, cool.
Yep. What else do we want to do? Do we want to make the gradient a little bit less boxy?
Yeah, that makes sense.
Yeah.
Is it boxy because of the dimensions of my window? Is it because
I mean, window's always going to be a bit of a box, right? So
right.
You're always going to have like that.
That's where it's getting that, right? Okay. Cool.
Yeah, exactly.
Squarespace, so not a sponsor of this episode. I don't want to get anyone confused.
Yeah. So let's multiply so above line 17.
And another raid. Ben, thank you for this raid. God. Oh my goodness. We have so many raids. Ben, thank you. Yeah, I really appreciate it. We're just working on some shaders. It's so funny. We've had like 3 raids in the past, like
finishing up their streams, right?
5 minutes. Yeah, it's fantastic. Thank you, Ben. I really appreciate. You had to cause chaos. That's so funny. Welcome. Cool. So we're gonna get this.
100%.
Yeah.
Yeah. So just above line 17.
Above line 17. Cool.
Yeah. Let's add a sine wave to coords.x.
So
coords.x equals coords.x.
Cool.
So sorry, what you want to do is you want coords.x probably times sine. So you could do it times equals, or you could just do it this way.
Got it.
Doesn't really matter. Yeah. And then inside the sine wave, you want that to be coords.y.
Ah, okay. Why? So that it's transversing on like the opposite?
Yeah, exactly. So you want
Got
sort
it.
of, and what you can probably do here is subtract I time from it, maybe. So coords.y minus I time.
Minus I
might
time?
give you kind of an interesting movement.
Got it. So okay, so yeah, this is where like it feels like it's moving to the right, but no, it's moving to the left. Like that's how I've been trying to figure. The one that you have for the template, and I'm not sure if you still have that template. If you could drop that in chat.
Yeah, absolutely.
Steve just raided with a party of 1. Steve. Oh, I love you, chat. You are fantastic. Oh my gosh. And apparently Ben was doing it first. He rated just for funsies. Yeah, so if you all use that as like a template, that's kind of where we started from chat. Just to give you an idea. Cool. So we've got Steve is currently alone right now. Cool. So we were yeah. So as I was saying, that rainbow template, I was trying to figure out, because I've seen that kind of effect before where it's like, oh, the colors are moving to the right, but then they like sweep back to the left, and I'm like, which direction is it coming from? How is this working? So that's kind of how it has a sine wave and also time. So it's like these two things that make it feel like it's moving in multiple directions.
Yeah, they're sort of competing
Got
against each other, right?
Got it. Yeah, right.
Yeah, yeah.
Cool. So now what?
Well, now maybe what we can do with frag color is play around with the colors a little bit more. So,
Okay.
let's maybe underneath line 20.
Yep.
Let's maybe do fragcolor.x equals smooth step. Let's do something really wild here. First parameter, let's make some arbitrary value, 0.1.
Cool.
Second value, let's make that frag color.y. And then third value, frag color.x.
Frag color.x. Thank you for the follow. Also, Brittany, yes, it's definitely a lot of math, especially if you're just jumping in. Whoa, what? That was wild. Oh my, that's so trippy. Yeah, as you said, like dipping into the psychedelic with shaders is just it feels like the first.
Super
it feels
easy,
like
right?
extra work to go towards like normal organic kind of stuff, or even towards like realistic feeling stuff, because you have this like cool Stage Mountains pen that feels like is it does it take a second to
shouldn't do.
There we go. Cool. It feels like paper, right? Like it feels like paper Stage Mountains. So this feels like extra work now that we've been playing with this to get it to feel like a real thing in a shader.
When I did this, I did a couple of programming nights with the developers at We the Collective to sort of do exactly what we're doing here, and it was funny. Like everyone's like just developing these psychedelic shaders because that's the first thing that you naturally do here, right?
Yeah, for sure. Cool. Okay, so we've got this frag color X, frag color Y. All right, smooth step, got it. Yeah, so just super quick for the chat, smooth step allows or basically returns a 1 or a 0 depending on whether this value, right? Or
smooth step is actually an interpolation, so it's
step
sort of
is
like
the one
lerp.
that's got it. Okay.
Yeah, exactly.
Got it.
Yeah.
Cool.
So smooth step gives you a lerp, and because we're using, so this would be a lerp if you were to change frag color.y to like 0.2 or something like that. That's lerping frag color.x between 0.1 and 0.2.
Got it.
Right. Whereas what we're in, give that a try.
That's, oh wow, this is so cool. Like it just feels like you can keep tweaking these values and adding these things and getting these like really neat results.
Exactly. Yeah.
And all at 60 frames per second. Like just it's just like this kind of like superpower on the web that once you can kind of figure this stuff out, you can create so many cool visuals that you can't with anything else.
Yeah, cool. Absolutely. Yeah.
All right, now what?
Oh, now what? Okay, so let's maybe do the same thing with another color, but using different values. So frag color.y.
So smooth step, same thing again?
Yeah. Yeah.
Cool. So just random like 0.2 or something?
I guess. Yeah. Like, let's see what we can come up with here.
Okay. I'll follow your lead on this. So if I frag color.
Let's make that Z.
Z, okay.
Yeah. And then frag color.y.
Wow.
Right, so you can see where they're sort of crossing over as well, which is kind of cool.
Yeah. And then this like white, like, I don't know. This is just really fun.
Right? Yeah.
It's so cool how many the different results you can get just from changing a few numbers.
Exactly. Maybe change that 0.2 to like -0.2 or -0.5 or something like that.
And Thomas says the mountains were giving him "Don't Starve" vibes. Are you familiar with that game?
Yeah. Oh yeah.
Yeah.
Thanks, man.
Yeah. Thanks for the follows. Appreciate it. Okay, so what did that negative just do? It just changed the
So
spot
just sort of
at which
move the
got it.
lerp over a little bit.
Cool.
Yeah.
All right.
Sweet. And then you could do the same thing with the Z component.
Oh right.
The...
I forgot about Z. Here I was. So this is essentially B. It's essentially no, yeah. RGB.
Exactly. So
right.
Actually, maybe let's do that. Let's change those to RGB components.
Okay.
So
R.
Yeah.
G.
Just to make it a bit clearer.
R. G. B. Oh, that's an N. And then G. Yeah. So for people in the chat, frag color is returning a vec4, which is which is kind of an array of 4 numbers. It's a vector 4. I don't know how to explain it, but the first value is red, green, blue, and then alpha. So we do have 4 values. Is fragcolor.a the alpha?
Exactly. Yeah.
Cool. Okay. Yep. So now fragcolor.z.
Yep.
Z equals, and let's copy this off.
Yeah.
So
one of the things that we can do here, because we are doing the same thing with the alpha value, but we're not sort of using it. We could use it here. So
okay,
let's make that first value, the first part of that fragcolor.a instead of exactly. And then you want the last value to be the B, or
this
we
one?
Can leave it there. Yeah.
Oh man, I like the peaceful white and then these like waves that come through. This is so cool. I love those colors too.
Right. So you see how you can just sort of play around with this, right?
Yeah, for sure.
Yeah.
Where? Okay, and the noise is coming from here. So if we didn't even want the noise, we could just drop that out, and we could just remove this addition. I just kind of want to see it without the noise real quick.
Yeah, for sure.
Oh, weird. The noise is blurring it more than I realized.
Yeah, exactly.
Wow, that comes in as a straight up line, and then the noise adds. How do we make the noise not as big? Do we multiply it here?
Yeah, exactly.
Cool.
So
let's go like
multiply
6.
that by 4 or 6. Yeah.
Go with 6.
Okay.
Trusted my gut. Yeah, I like that. That's funny. The difference the noise makes. You see how how not straight that line is anymore.
Yeah.
That's really cool. That's trippy. Fantastic. Liam, I love it. Is there anything else we want to do to this before we wrap up?
It's up to you.
I don't know what else to do. I'm following your lead entirely. I am clueless.
Yeah, I don't know. We could make a spiral if you like.
Sure. Yeah.
Okay. So this starts getting into like polar coordinates and stuff like that. Yeah, let me think of the best place to start here. Okay, so
just full context real quick for Ben. Yeah, Ben's on tomorrow. He's not saying that he's having trouble understanding the stream. He's saying, boy, this is going to be tough to follow. You're going to crush it, Ben. You're going to do great. I just want to make sure that you didn't take that, Liam, as like, boy, this is incomprehensible. I don't understand a word Liam's saying. Cool. Yeah. Just wanted to make sure that was clear. Cool. Sorry, spiral.
Yeah, for sure. So let's fork this out.
Let's what?
Fork it.
Fork it. Got it. Cool.
Yeah.
All right. Spiral. Call this one.
Yeah.
That's really fun. Let me actually drop that last one into chat if they want to check it out. Private. I'll also name it like gradient shader. Save, and there you go, chat, just in case you want to play around with that. I'll add all these to the show page after the fact, but for now, you can mess around with that. Cool. So we've got spiral, and we want to we'll wipe this out or keep it.
Yeah, let's wipe it out. Everything except chords.
Cool.
So what I'm gonna sort of be talking about here is gonna be a little bit incomprehensible in places, but I'll go through and explain it after we've got something in place.
Awesome.
Okay. So the first thing we need to do is create some polar coordinates.
Okay.
So it's a vec2. Polar coordinates are like Cartesian coordinates, which is what we've been dealing with so far, except that rather than an x and y component, they deal with length and an angle. Right.
Interesting. Okay.
Yeah. So what we want to do, let's create, so that equals a new vec2. The first component of that will be length of chords.
Parentheses chords.
Yeah, that's right.
Got it.
Yep. And the second component will be the angle. So we get that by using the atan function, so the arctangent.
In tan, like that?
ATAN. Yep.
Cool.
Exactly. Yeah. And then you feed that two components, the chords.y and chords.x.
You're definitely getting into math territory, but I totally expected it. That's
Cool. Yeah.
That's Shaderville, right?
Yeah, exactly.
Cool.
So let's make a new float below this.
Okay.
So this is going to be incomprehensible, but just bear with me. So we want to make a cosine, so cos.
Just like that?
Yep.
Cool.
And we want to, inside there, create... Oh, sorry, no. Float. My bad. Float
Okay.
spiral.
Got it.
Cos. Yeah. In there, we want a modulo operation. So mod, MOD.
Oh, okay. MOD.
Yeah.
That.
Yep. And then inside there, we want to add polar.x plus polar.y.
Right. I got to rename that.
Oh, yeah.
Cool.
And then the second component of the modulo operation is the interval over which you want to... Yeah, exactly. So let's make that 0.5.
0.5. Okay.
Yeah. So then let's make a frag color.
Okay.
Equals vec4. And we can just add spiral in there. Let's try that.
Because spiral is going to come back as a vec4 from... What the... That's freaking cool. Okay. So...
Okay, so let's fix this first, and then we'll go through it. So can you just scroll up there for me?
Sure.
I don't know whether you've got a tau constant. Do you? No, you don't. Okay, so under iNoise, add a let's do a define here. So under the uniform iNoise up the top. Up the very top, yeah. Yeah, that's fine. So hash define.
Sorry, what?
What we're doing here is we're creating
that
essentially a fill-in for variables. So
okay.
This will anytime we reference this variable, it'll just a WebGL will just fill it out with this value. So we want this to be tau, T-A-U.
Okay.
Yep, all uppercase.
Ah.
Yeah. And then in brackets, or in parentheses rather, you want this to be pi times 2. Oh, so space after tau.
So pi or capital Pi?
Capital Pi. So pi is coming to us from...
Common.
Common, yeah.
Cool.
So pi needs to be all uppercase.
Got it.
And the 2 needs to be a float.
It sure does. Do I need a semicolon here? Cool.
Yeah.
Chat. If you came in lately, you've missed about a solid 7 minutes throughout the whole thing of me going, Right. I need to add 0.01 because that's the thing you have to do in GLSL. Is that a thing for C and like every other language too, or is that?
It is, yeah, yeah.
Got it. All right. And
It would be a thing for.
Steve comes in quick with the yay. He's like,
So you can get rid of that semicolon there for defines. It doesn't. You don't.
okay, cool. Also, I just realized he did 0.0. You see how he's got the.
Uh-huh.
I'm not sure if you can see that actual emote, but he did a pointer emoji and the circle. Well done, Steve. I wonder how long he's been sitting on that.
Right, exactly.
All right, cool.
So what you want to do with the second component of your polar is you want to divide that by tau.
So atan?
So atan, yeah, and divide the. So after that atan divided by tau. Hopefully that'll fix it. Yeah, that fixes it.
That other one was cool too. Only thing it wasn't. Oh wow. That. Oh, okay. So it's a different spiral. I want to remove that real quick. This is more like fan blade. Oh, it didn't re-render. So this one's more like fan blades or something like that. I can't think of like what this is exactly. It feels like the top of like a soft serve ice cream, right? Like the sky view of that.
Yeah, right.
But now it's let me go forward actually. TAU. Wait, is that the right one? Yeah, I think so.
Yep, exactly.
That's cool. That's really cool. Awesome. So yeah.
What we can do there as well is if you multiply that tau by some value, let's say 5.
5.0 or 50 point nothing.
Yeah.
There you go. Cool. Okay, we go back to that
exactly.
other look, but now
now
it's
fixed.
Yeah, it doesn't have that noticeable break in the repeat.
Exactly.
Cool.
Yeah. So let me explain this a little bit. So polar coordinates, as I said, are defined by the length of the value plus the angle of the value. One of the reasons that we had to use tau in here is to correct for the sort of rotational variance, right? So those coordinates don't repeat in a way that make this sort of spiral work well. So we have to divide it by tau, which is 2 pi.
Okay, got it.
Right, which represents the entire sort of value of a circle unit. Yeah.
Cool.
Yeah.
That's really cool.
Yep. And then what we're doing to create the spiral is we're just adding the x and y components of that polar value together, which gives us this gradual largening of the values as they move outwards.
Got it.
Yeah.
Ben asks, to multiply tau by 5, don't we need parentheses there? And Brittany says, depends on which way you want to divide it by.
I said multiply tau by 5, but really we're multiplying the atan divided by tau by 5.
Got it. Would this...
Yeah.
Is that going to change it? Did I break it?
Yes. Maybe. You need another parentheses.
I do? Yeah. Okay. Keeps eating my second parenthesis. Oh, wow. That's like...
Right.
Tau's less attractive brother. Okay.
Right, because what you're doing there is you're saying, okay, multiply tau by 5, which I can't think of the value off the top of my head, which would be 30 something. And then divide atan by that, rather than dividing atan by tau and then multiplying that by 5. Yeah.
Cool. That's really neat. That's so satisfying. Cool. Are we doing anything else with this?
I think I'm done.
I think we're done. I think this is fantastic. I just don't want to cut you off if you're about to like put the sprinkles on top, so to speak.
I could keep talking about this for days and days.
I honestly, that's why we brought you on. I know that not only do you make a ton of these kinds of code pens and just blow our minds every time. Honestly, I would love to get good enough to understand why this is like so freaking cool.
Actually, I can show you through not this one, but the one above that.
Okay.
Is probably a better demonstration of that. So for anyone who's done anything in Three.js before, the only geometry here is that white cube.
This
so
box.
Yeah.
That the white lines is the mesh, and the rest is not mesh.
Exactly. The rest is all just shaders on the surface of that mesh.
Wow.
So with Three.js, what you use shaders for normally is to pick up lights and color surfaces of objects. Whereas in this case, what I'm doing is I'm using those directions, the directions of the rays from the Three.js camera to the object, and then projecting inside the object to create this other shape.
Got it. Yes, such like a cool cutout effect, and also like you've beveled the edges and everything. Like it's got some complexities for sure. This is so cool.
Mm-hmm. And you can do other stuff with this, which make a lot of sense. So let me link another pen here because it's actually in the We the Collective code pen channel.
Oh, nice. I forget that I forget that that's how I found you. I saw a We the Collective pen.
Oh, really?
That I wanted to cover. Yeah, remember I DM'd you on Twitter.
That's right.
Over a year ago. I saw your really cool carousel, and I was like, "Hey, I would love to cover this. Can you like talk about it?" And you explained how you.
That's right. Yeah.
You
totally forgot
We
about
the
that.
Collective whipped up your own custom carousel JavaScript. Your designer made an awesome the character design is really cool, and you were super generous in chatting with me about it, and I put it in the newsletter, and that was how we first met.
Yeah. Cool. So yeah, I just dropped a link in the chat here.
Oh, cool. Let me grab that.
If you click on that. So this is using exactly the same principle, but rather than rendering a cube, it's rendering a cloud.
That's cool.
Right, so this is a similar principle that people in video games use to draw volumetric.
Volumetric,
things, right? Yeah.
That's cool.
Yeah.
Liam, I totally hear you when you say you could talk all day about this stuff, because I think that this might be way more over my head, where like this intro to shaders I think was just perfect. But like,
for sure.
You could speak for another 30 episodes about things, and I would be fascinated. So I would
really,
love to have
really
you back
easily.
on sometime.
Yeah, absolutely.
Yeah, you just and the chat loved it absolutely. So
awesome.
Yeah, chat, throw some confetti emojis and stuff. Also, check out We the Collective if you're not already familiar. Are you still hiring for developers over there?
Not at the moment. I think we're probably on hold for that at the moment. We've just hired a couple of developers, Andrew Campbell, rather, our new junior, which I'm really excited about bringing him on board, and we're about to bring Amy Chuprick on board next week, which is
awesome.
Really, really cool.
Congratulations to them. You do some fantastic stuff over there. About us, or should I go to case studies?
Sure,
just trying to think of like a quick way to show off, kind of. I mean, first off, this site is just gorgeous, by the way.
Thank you.
Love the new site. Look at that guy. Yeah. So yeah, you've all been so kind. Andy Rubin and Marlon used to be with you in the chat. Just a whole bunch of kind people. You now have Steve Gardner. Just like powerhouse over there, and the friendliest people that I know. So love seeing you guys succeed, and love whenever I get to have one of you on. So thank you so much for coming around.
Anytime, Alex.
I really appreciate it. I'm trying to think what else we should end with.
I'm gonna drop the Book of Shaders link in here again, just because for anyone interested in doing this is a perfect resource for this.
Yeah, great call.
Yeah.
I hear nothing but good things. And if you are interested in shaders, we actually have a phenomenal shader artist coming up in September. Olithia's coming on for Component Carousel.
Awesome.
So excited to have her on.
I can't wait for that one.
She's fantastic. She's just she makes shaders practically every day, or at least very frequently, and really dips into the psychedelic stuff. Just does like really fun things, and she's been so generous and kind in helping me try to understand them a bit better. So I can't wait to have her on. She's been doing streams too, so that's gonna be great. And is this next week? Yeah, next week we have Lazar. I can't wait to have you on if you are still in chat. I'm not sure. Yeah, he is. He just emoted like a minute ago. So really excited to have you on. And of course tomorrow we have Ben. Ben, you're gonna do great. Don't worry about following it up. And we're gonna be booking more and more people. I'm excited for all the people that we are going to have on, and there's even more than this. I said to fill out the form, but Liam,
yeah,
thank
I'm really
you so
looking
much.
forward to Ben's tomorrow too.
Yeah, 11T.
Yeah, sure.
I got to play with it on Tuesday, and it was a blast. I can't wait for Ben to like take us a bit deeper into it. It's gonna be great. So yeah, drop a follow if you're not already following, because like I said, we're doing fun stuff all the time here, and we just got more and more shader stuff to come. But for now, I think we are going for the possum stream. Yes. I love it. I think for now, we are going to go find somebody to raid. I think our friend Mike is streaming. And here's the thing. He's streaming. He's doing a game stream for charity. It's a phenomenal charity, very near and dear to his heart. So we are going to raid him if he's still streaming. If not, we'll find somebody else. But please go in and show him lots of love. And let's support him. He's doing like a 48-hour game stream or 24-hour, something wild where it's like, wow. Yeah. He does it every year. It's for a phenomenal charity. So I already donated. I'm not saying you have to donate, but please support him and cheer him on if he's streaming. So thank you so much. I will see you tomorrow for Ben Myers. All right. Have a great day. Hang in there. I'll see you soon.